welcome also to everybody from my side. Good morning to everybody listening from Germany, and good afternoon to the participants from Australia. First of all, thanks to the Chamber for inviting me to speak here today. I really enjoy doing that. And of course, I would like to be there in personal in Sydney. I was there many years ago, very beautiful city. So greetings to Australia. And just two words about myself. I'm active in the field of energy efficiency since many years. I'm was working as an architect. I was doing research at university on sustainable building refurbishment. I was for many years working at a Hamburg-based project developer as head of project development, where we did large-scale energy efficient housing projects. And since many years, I give speeches, seminars. I'm active as moderator for this topic. I also consult energy companies on the energy transition. I will share my screen and then we can start with the presentation. I was asked to give a short introduction today about the topic of the conference, to set the frame a bit. I will focus on building installation and especially on building installation for residential buildings, but you can take all the findings from that also for office buildings, or most of that for office buildings and for industrial buildings, because it's really the basics about building insulation and energy efficiency and why that's so important for our targets. I will have about 25 minutes, and as Thomas said, if you have questions, please write them in the chat, and I will moderate the Q&A session a bit later after the presentation of the company. So please then don't hesitate to ask your questions, and I will try to, or we all will try to answer them in the chat, in the Q&A session later. Okay, so this picture you all know, Paris Climate Conference from 2015, which was an important step for us humans, because we acknowledged, or most of the companies, the countries in the world acknowledged for the first time that we have a climate change and that it's really a threat to all of us in the world. And we said we have to take action, and Franziska was showing it in her presentation a bit before, how the goals are and which goals we all set us. And these goals she was showing for Germany are similar in the whole world. So by 2045, most of the countries want to be CO2 neutral. So that's, of course, an important step. And we had a lot of follow-up conferences, but the problem with that is we talk a lot, but we don't get into action. Time is running. We have about 20 years to get into action to reach these goals. And so that's not a lot of time. So we have to start to take action and to stop only talking about it. So that's why I think this conference is such a good opportunity, because the companies are presenting real solutions. They are presenting technologies which we can use today, and they're trying to find partnerships where we can take action immediately. And you will see from my presentation, from the following up presentation, that there are all the technologies there. There are all the solutions there. We don't have to do a lot of research anymore. We can start, and we would like to encourage everybody to do that right now. Because if you think of a city development, which you start to plan today, and I was doing these city developments, it takes at least 10 to 15 years till the first buildings are ready, till the people move into these cities. And if you do that now, we are almost at start today, we are almost at 2045 when these city developments are finished. So what that means is that if we want to change anything, if we want to reach our goals, we have to build now in a way, in a correct way, in a future-proof way, which is already doing now what we need in 20 years. So we don't have the time to say, okay, we do a city development half the way, we do a bit of city development, and the rest we will do in 10 years, in 15 years. No, we have to really change now. I would like to encourage by my speech, and I think the others too by their speeches, to do that. So to the basic topic of my presentation. What can we do in the technology sector, in the building installation sector? What do we have to do? What can we do? Of course, the one main pillar of energy efficient buildings is the insulation of buildings. It's like a coffee pot which keeps the coffee warm. The building installation keeps the energy inside of the building, and it doesn't matter if it's a cool building or a heated building, the energy should stay inside as long as possible. This is not my topic today, but this is just a remembrance. This is an important topic to think about. A step before doing the building shell, thinking of the building shell, you can think about different stages in planning. If you look at the left building, this is a classical view of a city, especially in warmer climates. Looks fancy. I'm sure it's very nice buildings, but they have one disadvantage. They use a lot of glass. There's no shading. So they are heated up by the sun, and that puts a lot of energy into the buildings. And that energy has to get out somehow. And these buildings need a lot of energy to be cooled. And by starting in the planning phase, you can think about different measures. You can green the roofs, the facades, you can put shades on the buildings. So the planning stage, the thinking about the principle of the building is very important at the beginning to have a well-designed building which is not consuming a lot of energy. Then you think of the building shell, how to keep the energy which you still have to provide as long as possible in the building. And then you have the second big pillar, that's the rest of the energy which you still use. And even passive houses use a bit of energy. It's not much, but still they use energy. That should be provided by 100% renewable sources. And Franziska was showing this slide in a bit different form, but the same figures. We have a lot to do in Germany concerning this target. We are by less than 20% share of renewables in the heat market, and we are a heat-driven country, so we have to heat our buildings mainly. Cooling is not so important for Germany. It becomes more and more important, but so this share has to go to 100%, and as we were saying, very quickly. So we have to think how we can reach that goal, and what we can do on the installation side to get to this goal. One main topic in there is the ventilation of the building. It's a technical aspect, of course, and the newly built buildings have to be in Germany, and I think in most countries of the world, more and more air tight, so that you don't lose energy through uncontrolled energy through cracks, through cracks in the outer wall. So you have to do something about ventilating the building. Of course, you can open the windows, but mostly this is done by ventilation systems because it's comfortable, it's easy, you don't have to think about opening windows. And if you build a ventilation system into these buildings, then it's wise to equip it with heat recovery so that you keep the energy inside of the building and that you don't ventilate it out by opening the windows. Here you see a good example of how you can do that. This is a decentralized ventilation system with heat recovery. The ceramic block, which you see there, is the storage of the heat, of the energy, which is pushed out of the building, and it will stay in the ceramic block. I think Lunos is there to explain that a bit later in more detail, so I will be brief on that. And this is a technology which you can really use in existing buildings. You can also use it in new buildings, but for existing buildings, it has good advantages because it doesn't take a lot of space. You can drill holes in the outer wall, like you see on the right side, and you plug in these ventilation systems, and then they start working there. They start ventilating the building. And by these measures, you can save 75, 80, 85% of the energy which is inside of the building, or that you can save, let's say, the ventilation losses or reduce them by 85 up to 85%. If you have a more space inside of your building, you can also use technologies like this for ventilation. This is a centralized heating ventilation system where you have it installed in a central room, like the kitchen, for example, or bathroom. And from there, you put the fresh air to the different rooms by pipes, and you suck out the used air from these rooms also by different pipes. and bring it back to the ventilation system, where you cross the air streams and you do the heat recovery there in this ventilation system there. All the most of the ventilation system have an advantage when you think about cooling. First of all, they push out the heat load that is and regularly, not just 2 or 3 times a day by opening the window, but all the time they push out the old, used and heated air. And if you need more cooling, you could equip the system with something you see on the right side. This is one example how you can pre-cool the air. It is a grid, a metal grid. The air flows from the left to the right. The warm air is on the left. The right is after passing this grid. And the grid is moistened by water. And by evaporating this water, the air is going to be cooled. So you just need water and a bit electricity for the fan. And then you have a system where the air is pre-cooled. This is not replacing an air conditioning. It's not the same effectiveness as an air conditioning system. But if you use measures like that, you might be able to reduce the heat load in a way that you can that you don't have to use an active air conditioning system, because that might already be on the bridge on the brim to be enough. So this was the basic topic of ventilating buildings. And then we have the second topic, which is of course very important. How do we get the energy inside of the building, either the heat or the cold in warmer climates? And if you look at the German heating market, then you see a clear trend. This is the installed heating system in new buildings, and you see that we have more than half of the buildings are equipped with heat pumps. And then we have about a quarter, which is equipped with district heating. And this is a clear trend in Germany. And the government wants to achieve these goals to really heat all the buildings or most of the buildings with heat pump and district heating. And they set their goals on these targets. And I will explain the following slides why. The heat pump has many different advantages. Wherever you can install it, it is, in my opinion, wise to do so, because it is first of all, a very effective heating system or cooling system, because it uses a little electricity to run, but it uses a lot of energy from the surroundings, from the ground, from the air, and even from other heat sources like wastewater and so on. And so it's a very effective system, and it can be run completely 100% renewable. The electricity, if it comes from the grid, can come from 100% renewable sources. We're seeing the figures where we want to get by 2030. So 80% of renewables in the electricity in the grid is really a high goal, but that would mean all our heat pumps would get more renewable. And if you can also provide the energy on site yourself. Also, a second opportunity you have is you can use the heat pump for heating and for cooling. You can actively cool with the heat pump, and then it's just put on reverse in summer and it's cooling the building. Or you might even not cool actively, like you see on the right picture. This is basically water which is running through the ceilings or walls, concrete ceiling or walls of a building through pipes, like you see on the right side. And the water comes from the heat source in winter of the heat pump. If you look at the figure B in the left picture, this is a heat exchanger which is drilled into the ground. They are normally 80 to 120 meters deep. And in about 60, 70 meters, you're starting to have temperatures in winter and summer of about 12 to 14 degrees. So you can use this temperature to pre-cool water in summer and to run it through these pipes of the building to cool the building. So this is also a very low P strategy. You don't need a lot of energy to run these pumps, and you can pre-cool the house by doing that without an active cooling system. Of course, you can use, like I mentioned, renewable energies to run your heat pump on your own roof, solar PV. You can also support it by solar thermal energy to produce warm water, to store it in storage tanks. And the heat pump only kicks in if you need special energy because people are showering or taking a bath. A The second pillar I was talking about, the second strategy for providing energy to the buildings is district heating. And why is that so? Because it is more, if it's done in a correct way, it's more efficient than building a heating system or cooling system in each different house. Because there you can imagine you need much more material. It's smaller engines or smaller heat systems, which are not as effective as larger and bigger heat systems. So it's a good way to save energy, to save material, but it has a second advantage. It's also a good way to put energy sources into this grid which are not suitable for single houses because they are too large scaled sources. Like in the middle, you see a big pipe. This is a wastewater pipe. And this is the heat exchanger, or in this case, it's equipped with a heat exchanger for a heat pump, a centralized heat pump. You would not do that for each little house, install a separate heat exchanger, but that is suitable for larger heat pumps, which then use the ground source as heat source. And also, of course, that's also possible for cooling. And then you have larger options like pellet ovens, large pellet ovens, which produce heat for the connected buildings. Or you see it on the right side, you can take the industry, the heat which is generated by industry. For example, steel industry is producing, for example, a lot of heat, cement industry, and you can take the heat to put it into the grid and to provide it for all the households. And that comes basically by free because it's produced anyway. Of course, this is not only about heating. You can do the same thing with district heating for district cooling. This is something which is called an absorption chiller. You will hear in the following presentations some more about it from the companies. So I will not explain the technology. You will hear about it, but the idea is that you use a heat source to produce cold water. And the cold water can then be provided to the different households to cool the households in summer. And here in where you have warm climates and where you need to cool buildings, normally you have good heat sources like solar energy. So you can equip these machines with solar thermal panels to provide the heat for these cooling pumps, which then produce cold water. And of course, you can run them by renewable electricity. So in the end, you have a very renewable system or working on renewable energies. Also, a technology which you might use in a district heating or cooling system is this. This is a so-called ice storage tank. It's basically just a big tank filled with water. And it is the heat source for a heat pump. So the heat pump in winter in Germany starts to take the energy from this water, cools it down, and at a certain point, this water starts to freeze. And when water is freezing, it sets free a lot of energy, as much energy as if the water is cooled from 80 to 0 degrees, it is setting free when it's freezing. And this is, of course, energy which the heat pump can use. And you have a second opportunity in summer when you need to cool the buildings. You have a large block of ice. And of course, you can use this cold water and the ice to use it for the heat pump to cool the buildings. But all these technologies are, as you can imagine, not suitable for small households. You would not build this for 100 times for different households, but you build this centralized and connect the 100 households with this technology. One thing I would like to mention in this context is that's not only the technology providing energy, which is important, but also how you steer and measure the energy which you use. There were different research projects which were done to see how much is the effect if you use smart homes to control your home and how much energy you save with that. And here, these are average figures. In each household that might differ, of course, but it's around 18% which you save or can save concerning the heating, 31% concerning the light, 11% concerning the warm water. And if you look at the lights, that's a good figure. Almost a third of energy which you can save by using smart home technology, it's explainable because you have two things. First of all, it's very comfortable to run your building. If you're standing at the door, you want to leave, and you think, oh, I forgot to turn off the lights in the upper floors. Normally, you will not go up there and turn that off and then leave. So you leave it on and you say, well, it's just light. And that's if you have a smart home system, you just press the button and all the lights go out in the building. So that is one way to save energy. The other is because the people start to know how much energy they use. They see their energy bill daily. They see how much energy they use. And that makes them think about it. And that makes them to think maybe I would like to save a bit of this money which I'm spending every day. So the awareness is also a very important factor here. So these are basic technologies and options we have, and they are there. We can use them every day. And it's of course always hard to integrate that in the projects because if we talk to our customers, if we talk to the builders of a building, you always hear the argument, yeah, that's nice, but it's expensive, and who needs that? It's okay, it's good for the climate, but that's it. And that's not really true because we have a lot of marketing arguments coming with these technologies. We have in energy efficient buildings, we have a very high comfort. Think about the ventilation system. This is not only saving energy, but it's providing you with fresh air constantly. You can put in filters and so on. So it's a comfortable way. The insulated walls, they provide a better comfort concerning the outer walls and so on. Then you have a high quality because normally energy efficient buildings, the planning and building process is closely monitored. That means that people look very in detail if the building physics are correct at these buildings, if this is correctly done according to the building physics. And that means you will have less problems later with the building, less building damages. And then, of course, you have lower costs. At the beginning, you have to invest a bit more, but the buildings will stand much longer than 10 years. And in the long run, you will save energy costs. And if you think about a gas system, which you have in Germany today, every year the prices will rise, not only because of crisis we have, but also because we have a CO2 tax, which is getting higher and higher every year. And so it's predictable that we will be at very high costs in 5 to 10 years. So it's wise to change to a new system now. So all these are marketing arguments which we can use if we want to sell our energy efficient buildings, and which we should use because we're doing it in other regions or other sectors of the building already. If our customers want to have a nice kitchen, there's plenty of magazines showing them what a nice kitchen is. You want to have a nice kitchen and spend a lot of money on that because it's just comfortable. It's nice, it's sexy to have a good kitchen. And if you think about energy efficient buildings, of course, they are also comfortable, like I was showing, and they're sexy too. They're state of the art buildings. And you also save energy with it, and you're doing something against the climate change. So you have even more advantages than if you compare it with this kitchen here to invest in energy efficient buildings. We just have to communicate that. I think we're doing a bit the mistake to always say we have to do it because of the climate change. Of course, that's true, and that is the main goal. But we have other options to tell the people why this is for them. It's good to have these energy efficient buildings. This is just a project to show or to see that this is still not the reality everywhere in the world. Not in Germany, not in other countries. This is here an example from Belgrade in Serbia, where they built in the moment, or it's almost finished, a very nice city development, a quarter with many, many houses, which is very expensive, and they do a good commercials for that, but they forgot, in my opinion, completely about the energy part. If you look at all the balconies, and there's a lot of balconies, this is just one house of many, many houses in this area. And on each balcony, you have an air conditioning system. This is, first of all, very expensive, a centralized, if you need an air condition. And I'm not sure that you really would need one if you build a building correctly, even in warmer climates. But if you need one, then you can do it centralized, and that saves costs, and not only in installing, but also in running these systems. And it's also not at all comfortable, because imagine you're living in this apartment and you have a constant noise on your balcony, and it's pushing the air, either on the warm, hot air, either onto your balcony, or it's pushing it onto your windows, where you might have the sleeping room behind. So this is not really a very comfortable solution. And I think they missed an option here to do a very good energy efficient system and to do commercials with that and say, this is state of the art and you get an additional value with your building.
Sorry,
so
Daniel.
With that, I'm at the end of my presentation. And this is just a picture to remind you that where our goals are, where we want to go. This is how we should think of our future, of our buildings. We should start today. We should start now to build green, livable cities, which are not only doing something to prevent the climate change, but are doing something to make us a good surrounding, to provide a good surrounding for us people. Do we have to need cars everywhere? Can't we use the space for green, for the people to live there instead of to parking our cars? This is not the topic of today, but this is also something where we could think about. So I want to encourage you to use all the technologies to build green, livable cities for the future. And then I want to wish you a good continuation of the conference, and we see each other a bit later for the Q&A session. Thank you very much.
Excellent. Thank you, Daniel. I like the central message of your presentation, and I really like the way you tied in the companies that are part of the delegation. We'll see you shortly again. So now I would like to welcome Dr. Franka Kretschmer from Fahrenheit, and she will give a brief presentation about their efficiency booster absorption cooling.
Thank you so much, Thomas. Hello to everybody, also from my side. And yeah, thank you, Daniel, for already give a short reference to absorption, and I will talk about adsorption, but mostly it's thermal cooling. So I will share my screen and just give a short. I try to keep it short. So I hope you can see my screen. Can I get a short?
Yes, looks good.
Looks good.
Yeah. Okay. So Fahrenheit makes cooling of heat, and the physics are very complicated. And I just want to give a short idea of what happens there, how to make cooling of heat. But first, I want to introduce myself. So I'm an engineer for energy, and I'm working as a technical business developer in Fahrenheit, and so we are looking for partners for use cases and stuff like that. So don't hesitate to contact me later on or in the question session. Yeah, I mean, the frame for why we have to do that is already clear. So I will start exactly with these kind of showing the physics. On the left side of the bubble, you can see a material we are using in the machines, which is heated up by solar heat, by waste heat, by industrial waste heat. And what happens is water is sucked by this material when we open the valve. And by this evaporation, what happens, because the material is like a sponge, you can get cold of this process, and this is the cold we then use in our products. And what we can offer is 80% energy saving in comparison to compression cooling systems, because cooling is not in Germany, but in many parts of the world, it's a very high energy demanding technology. So we really need to have to think about how we can face this it's getting hotter. Everybody buys HVAC systems, and this doesn't make the problem better. So we really have to change this kind of cooling supply. What we also can mention here, that we just work with water as a refrigerant. So we also have here the GWP of 0. We work with materials which are not which are inert, not react, and so they are not hazard or any dangerous in any way. These machines has also almost no maintenance, so they just run because we don't have we have this physical process and not a mechanical process, which is demands many maintenance. And we can use hot water up from 55 degrees, so it's also interesting for data centers and stuff like that. Compressed air systems, CHPs, etc. We can cool water down to 6-7 degrees, depends on the conditions, on the recooling systems and stuff like that. We can make machine cooling with this. This is our main field in the moment. Cooling processes, production sites, battery systems, IT centers, and of course building ACs, where we also have some references already in Australia. And here you can see a system set up for solar cooling, for example. Yeah, we have solar tubes, solar thermal tubes on the roof. We need a hot storage water to make it more continuously. Then we can use one of our machines. Here you can see a hybrid chiller where we couple the adsorption process and a compression chiller to make some peaks available and stuff like that. Then we use a cold water storage, and we would suggest always to use something like a cooling ceiling, where you have a big surface to bring the cooling into the room, and especially by radiation and not by convection. This makes our machines very effective in this moment, and Daniel already told something about the usage of ceilings. So this is something what is really coming. And for this solar cooling systems, we have some EU projects which are very interesting, coupled in different ways and different kind of buildings. This is very interesting to take a look on. Here you can see our machines, the small ones for really solar home cooling. This is 5 to 15 kW. Then we have our normal machines for industrial usage, up to 100 kilowatts. And then nowadays we started to build some ready-to-use solutions in this kind of container, especially for bigger buildings. We have some partners where we are working together, and also in industrial usage, there are sometimes big amount of cooling demand, so that we cascade our machines and make bigger systems out of it. On the same reason Daniel mentioned, you need one bigger pump and not 10 small ones, so we cascade this and makes it more efficient. And also we have a combination with propane chillers, so also GWP 0 to combine with our adsorption technology. Yeah, that's it. Thank you so much. I hope I kept the time more or less.
Yeah, thank you, Franca.
And
That was great.
I'm happy to have some questions later on. Thank you.
Exactly. If anyone has any questions, pop them in the chat and we'll get to them during the panel discussion. And hopefully we get into a little bit more about how it works, because I've seen it a couple of times now and it's still a bit of a mystery to me. I would like to learn more about that. So next, could I invite Jonas Fleischmann, Business Development Manager for Orkan Energy. So similar input but different output. This is clean electricity from waste heat.
Yeah, hello everybody. Thanks for the kind introduction. I hope you can see my screen in the correct mode.
Yeah,
I'm
looking
not
good.
so familiar with Zoom, only Teams. Yeah, my name is Jonas Fleischmann. I work for Orkan Energy as business development manager. As Thomas already said, we can turn waste heat from industrial buildings into electricity, so carbon neutral electricity. We're active in many different industries, as you can see on this slide, and have already some commercial references in the oil and gas field, on river cruise ships, on geothermal plants, also engine power plants, and zinc smelters, or some more cement plants in Germany. And so far, we have marketed over 600 of our solutions with more than 7 million operating hours, and saved with our solutions approximately 170,000 tons of CO2. Yeah, how does our process work? The principle is the so-called ORC, organic Rankine cycle. So basically like a steam turbine, but working with an organic working fluid, which evaporates at lower temperatures and pressures. And therefore we can also use lower waste heat temperatures for our process. The working fluid is evaporated in the evaporator, then in the expansion device, the expansion takes place, turning generating mechanical work, which is then converted via a generator into electricity. In the condenser, the evaporated working fluid is liquefied again, then pressurized again, pumped to be fed to the evaporator. On the bottom, you can see our product portfolio. On the left-hand side, the air-cooled versions in a 20-foot container or a 40-foot container, and on the right-hand side, a water-cooled solution for sites where there's cooling already available. Yeah, our integration is quite standardized, with either taking directly hot water into our modules, or if you have a gaseous heat source, we can install a heat exchanger, which then transfers the heat from the exhaust gas or exhaust air to a hot water loop, which then feeds one to several of our efficiency packs. Here on the bottom, you can see the industries in which we're active in. But for now, I just wanted to bring a reference to your attention. This is Wittekind. It's a cement plant in northern Germany, where we use the heat of the waste heat from the clinker cooler, which is basically coming out through this tube. There we have installed the heat exchanger I've showed on the slides before, transferring the heat to the hot water loop, which is then ducted below the street and going to a technical building, where it's split up to 6 of our efficiency packs, our modular C modules, which then produce approximately 1.1 megawatt electric power, and which leads to scope 2 CO2 reduction of approximately 4,000 tons per annum, and additional electricity saving of 8 gigawatt hours. For our potential customers, we have created a very simple questionnaire where they can hand in their heat data, so we can make a good evaluation to give them a first indication of how much electricity can be produced from their waste heat, which CO2 savings this electricity can be affected. Also stating, of course, the net electricity power, and giving our customers an indicative price. Yeah, thanks for your attention. I'm looking forward to receiving some questions. Now I just need to stop the sharing my screen. Cool.
I was able to do it for you. That's all right.
Yeah, perfect. Thanks.
Okay.
Sorry, as I said, not familiar with Zoom.
No problem. No problem. Yeah, I like that at the end. Heat check. That's clever. That's a good title for the data sheet. Thanks for that presentation, Jonas. And we'll be seeing you shortly in our panel discussion. And so now I'd like to ask Jonathan Kohlenberg, who's Senior Sales Manager for EcoPhi, to take the screen and give his presentation, which is monitoring and control solutions for digitalization and optimization of energy systems.
Yes, thanks a lot. I don't know if you can see my screen actually, because this, for some reason, not properly displayed.
Jonathan.
But you can see it. Okay, perfect. That's all I need to know. Yeah, good morning, good afternoon, wherever you're currently based, we're currently located. I like to give you a short introduction into EcoPhi, or EcoPhi. It's really it's pronounced differently all over the world, basically, but we can call it EcoPhi for this purpose right now. We are a small company in Germany with around 15 employees, based in Karlsruhe, southwestern Germany, with the focus on monitoring, control, and optimization of all kinds of energy systems, basically integrating all system components in one big logic which controls and optimizes an energy system. We are originally from the PV area. We used to do PV installations ourselves, but since 2020, we are now fully focused on monitoring and control systems. Regarding buildings, I can integrate this more into our presentation, that this whole conference is about buildings. But as I said, the full focus of us first was on solar, but since then we've integrated EV chargers, batteries, heat pumps, and also all kinds of ventilation systems. So basically, if you have a building which needs to be optimized, where the energy components which sort thereof don't really communicate with each other, or they communicate on their own but don't really build a communicating network with each other, we can optimize this. So what we do is we have developed a combination of hardware and software. So first of all, we have our EcoPhi boxes for different purposes. They communicate directly with the energy component, so with an inverter, battery, EV charger, heat pump, ventilation system. Every system basically that can communicate or is a controllable load, let's say it like this. So we connect our box to the controllable load, and we can also add additional sensors for environmental measurements, like irradiance sensors, temperature, humidity sensors, so basically to give you an understanding of the surroundings. What we often do with solar systems is that we, on one hand, communicate directly with the inverter and gather all the data on the inverter, but also compare the current irradiance to the actual output of a solar system to see if it functioned efficiently, basically. So we are aware that most of these components have their own monitoring, but these are usually not smart together. And if you have several buildings, let's say you install several systems, you have many components, then usually you have around 10 to 15 different platforms of these different manufacturers, which you have to check regularly. We bring everything together in one platform. And this brings me to the platform part. So our box which is on site sends the data via GSM to our platform, and we display everything in one central platform. We optimize this. We have several algorithms which basically optimize the system. What we've done recently a lot, because of dynamic energy prices, dynamic electricity tariffs. What we've done, for example, in the Netherlands, they have this problem that energy prices, electricity prices go way into the negative range sometimes, because they have a lot of wind in their energy mix. So when you have high negative energy prices, once you're feed into the grid, you basically pay a fine instead of getting rewarded for it. So basically, we can monitor your system and control it based on the current electricity prices. So via API, which you can see here, we can integrate all kinds of data via API and manage your system not only by the local data which we gather, but also via external data which we gather and integrate via API. Everything is visualized in an asset management overview, so you see all your systems, all your buildings, all your components, whatever you want to distribute this. You see them in a big overview, and you can see the single systems as well. And then from this, we can not only generate like regular monitoring where you can log in and check everything, and automatic control functions or manual control functions, but you can also receive reports. You can set alarms if some thresholds which you define yourselves are reached, and of course understand your performance better of the system, whatever this is. So I mean, this can be applied to your individual system. We are originally, as I said, from a solar background. But if you only want to optimize like a battery, which you have in your building, usually in an industrial context, or you have maybe 10 different machines, which you want to monitor individually to understand which of them are the larger energy thieves, because you only receive a monthly electricity bill and you don't understand where this electricity consumption is coming from. Basically, we can give you a much better understanding there. So which brings me to the second topic of our energy consumption monitoring. So we don't only focus on this solar battery EV charger monitoring, but we also have developed another solution which has a central measuring unit, and then with cable-free communication via LoRa, usually we can monitor up to 50 different measurement points within a facility. For example, you have 10 different machines in an industrial context, or in a residential context, you have 20 different apartments, and you want to understand the individual energy usage, energy consumption of these individual apartments, for example, then we can monitor this. So I see that I'm almost already, I've already used my time. We can go into the details, yeah, maybe of our hardware just a little bit, just to understand what we do. We have 3 different boxes, which can be used for different systems. Basically, in the solar area, we've monitored everything between 1 kilowatt and 11 megawatts. So for all different sizes, battery-wise, also the same, like several hundred kilowatt hours of batteries, all kinds of EV charger manufacturers. So there we've integrated many manufacturers. So to summarize this, we have meanwhile developed a lot of algorithms, a lot of functions for different different challenges in the energy consumption, energy mix. So if you as a company have specific challenges that you're dealing with, either you only want everything just on one platform, or you need something to be optimized within your energy consumption, or you just want to understand where you can save more money just by, for example, managing your system with the current energy prices. For example, in Germany, dynamic energy prices, electricity prices are coming next year, mandatory. They have to be offered to private persons next year. I'm not 100% sure how this works in Australia right now, but I'm sure that this issue will come as well if it's not there already. So this is just to summarize what EcoPhi does. Yeah, and I can send around my presentation if you need it, even though I didn't need it right now. Thank you for your attention.
Thanks, Jonathan, and thanks for being mindful of the time. Appreciate that. And so we'll see you soon as well in the panel discussion. And so I'd like to welcome our first Australian expert, which is Jeremy's already got his presentation up. He's very quick. He's the head of policy at the Energy Efficiency Council of Australia. He has experience in the Victorian government. He has experience in the International Energy Agency, and he has a lot to say about building efficiency in Australia, building energy efficiency in Australia. Thanks, Jeremy.
Thank you, Thomas, and thanks for your patience, everyone. I'm going to try and zoom through these quickly. What I wanted to do with my presentation was provide the German companies who are online a bit of context around the Australian market. I've seen some comments in the chat actually coming up with other people who are on the call giving some context about Australia, and I'm aiming to do that now as well. And hopefully that can stimulate some questions in the next Q&A session we have. So I'm going to get on with it now. The Energy Efficiency Council it's not focused just on what you would consider traditional energy efficiency. We're also looking at electrification and demand flexibility. So we are the industry peak body that advocates on behalf of businesses like some of the businesses we're seeing on the call today, in order to improve the energy performance across the Australian economy. We also work on helping to boost skills in the workforce to deliver better energy performance in Australia. We have a whole program of training. And generally speaking, our mandate has really shifted now towards this decarbonisation challenge that we heard Daniel present in the first presentation. Formerly, the Energy Efficiency Council, we just cared about efficiency no matter what fuel, but now we are very much focused on electrifying Australia and trying to decarbonise the economy as quickly as possible. Our members are very diverse. We have everyone from universities to small city governments. You can see the City of Sydney represented on this slide. And then we have lots of big companies as well. You can see Origin Energy, one of our companies that is a big Australian energy retailer. We have equipment manufacturers, Weissmann from Germany, Stiebel Eltron from Germany as well. So we represent a company who is trying to sell products and services into the Australian market to improve the energy performance across businesses and households and industry. If you want to find out more about membership after this, please get in touch with me. My email address is at the end of the slides. So now to give you a bit of context about the Australian market and the Australian energy and emissions in buildings. So first of all, these are some data from both Germany and Australia from the International Energy Agency, so you can compare the difference. Residential and services is what I'm circling here to show you that that's around 1/4 of our energy use. It's much higher in Germany from the residential sector in particular because of your heating loads. But we'll talk a bit about heat now, or heat in the next in the slides coming. We're looking at emissions when you circle just the residential and services sector. I'm just taking services as a proxy for commercial buildings here. It's about 30% of our energy-related emissions are related to buildings, which is the topic of today. Now, one of the things that people might find a little surprising about the Australian context is that when you look at our energy use, we actually have a fairly large proportion of our energy use in the residential sector, this is, going to space heating. You think of Australia, you think hot climates, but if you look at the dark blue part of this stacked column chart, you will see that space heating is still the largest end use when it comes to Australian residential consumption. And that's because we have promoted for many years, particularly in the state that I'm calling you from, Victoria, the use of natural gas for heating. That is the reason for that large blue segment there. That is changing because in the east coast of Australia, at least, a lot of the natural gas is starting to run dry. We've exhausted the natural gas wells in Victoria, just about. And so we're looking at shortages here. So the government here, for example, has recently announced a gas substitution roadmap and would like to transition all of these residential gas heating loads over to electricity. You'll also see there's a fairly big orange segment in our energy end uses in Australia, and that's for water heating. And again, we've prioritized gas water heating instead of electric water heating for many years because our electricity system was very dependent on coal-fired power, and we saw gas as a cleaner fuel. Now that's changing. We want to get off gas for water heating, and we're looking at heat pumps as well. So just to show you that there's some variation in location across Australia, the colder states, ACT, Tasmania, Victoria, for example, you can see there's a much higher use of energy for space conditioning there, and that's what I talked about earlier, the gas used for space heating, and water heating also in that segment. One of the unique things about Australia is that we have a lot of rooftop PV, and that's shown here in this red segment. This is a typical generation of electricity in the national electricity market, which covers all of the states except for Western Australia. And you can see that in the middle of the day, a really, really large proportion of our electricity is now coming from rooftop PV. So that's that large segment at the top there. The yellow segment just below that is a utility grade or utility size PV system. So really the majority of our PV is rooftop. And that's what makes Australia quite unique. It means that there's a huge potential to tap into that PV but it's going to require a lot of retrofits. Like I said, we have a lot of gas hot water systems, for example, turning those to electricity and then making those use the solar PV that's being generated in the middle of the day is the key challenge we have now in this country. In contrast to the rapid uptake of PV, our building insulation is extremely poor in the residential sector, at least. As you can see here, in fact, our data is quite poor even. To find out what's going on in the Australian building sector, it's really hard to get good data. This comes from our national home energy rating scheme, which is not mandatory. It's voluntary at the moment. Well, for new buildings, it is mandatory, but for old buildings, it's not, existing buildings. So we don't really know what the existing building stock looks like. But from the data we do have, we can see that there's a lot of buildings that have no insulation or less than R1.0. When it comes to the very highest insulation, R6, R7, there's really barely any buildings with that level of insulation. So there's a lot of improvement that can be done to insulate our buildings and improve their thermal performance. And at the Energy Efficiency Council, we are advocating very strongly that Australia should spend more time on improving its thermal performance of its building stock, because otherwise we are going to waste a lot of energy. Even if we have that amazing PV resource, in the evenings, it's not going to be there. So it makes sense to invest in our building stock and improve that before we go and do things like buy batteries. On the commercial buildings front, we have something called mandatory disclosure of building energy performance for offices. And you can see that has had a huge impact. By making that mandatory, we have seen really, really good improvements in our office energy performance. And this is something that we are exporting to the rest of the world, the neighbours system. So this is one of the success stories of Australia's energy efficient buildings. There is still a lot of potential there in commercial buildings. This chart just shows you energy use by non-residential building type on the left. And so offices that we've just seen in that last chart, that is the blue segment there, around 25% of energy use. But all of these other segments are not subject to that mandatory performance reporting requirement. So there's a lot of potential there to improve the energy performance in those commercial buildings. On the right side, we see emissions from commercial buildings, and the vast majority of that are emissions from electricity. There's this small blue segment of scope 1 emissions, which is the direct emissions from these buildings, and that's from gas combustion in those buildings, but the vast majority is electricity use. And that's why I've said in the slide heading, there's a lot of potential to retrofit these buildings to be grid interactive and use some of the things that we just heard from EcoPhi rather, to optimize these commercial buildings and use them effectively as batteries so that they are switching on and off at times that are useful to the grid when you have that excess solar. Look, the Energy Efficiency Council has done some work with some of our members, including ANZ Bank, to look at where we think decarbonisation of the energy sector should come from, between now and 2050 to meet some of the targets in the Paris Agreement. Energy efficiency should be done, from now to 2030 immediately, and onwards to 2050 as well. And electrification is a big part of the story for us. We see electrification playing a huge role. Switching over from gas boilers, for example, to heat pumps is a big part of that, and that really needs to start happening, particularly in the second part of the period to 2050 from 2030. And finally, how are we going on improving our energy intensity generally? It's been improving from around 1 to 2% on average annually. The last couple of years, at the end of the chart, I've got both primary and final energy intensity improvements here. That's the amount of energy used per unit of GDP. And in the last couple of years, it looks like we've done better, but to be honest, I believe there's a big impact of COVID there. So I wouldn't take those last couple of years into account. And if you look at the historical period here, it's goes up between 1 and 3%. But I'm more interested in final energy intensity because that strips out the impact of the shift to renewables in Australia. And so really our demand side has a lot of improvement to go. There has been a lot of policy development. I won't get into the details of this slide. We can talk about it in the chat, perhaps, in the Q&A. The one thing that I wanted to highlight is that just on Friday, the federal government announced a new national energy performance strategy. This is something that the EEC has been lobbying for the last couple of years. Unfortunately, I would say that the strategy signals, an interest in doing more to improve our energy performance, recognizing the importance of energy efficiency and electrification. There are no hard targets in that strategy. Like we heard from the first presentation from Franziska, Germany has these targets for improving energy efficiency. In the strategy that was announced on Friday, there is no target. There's nothing saying, we will improve our energy performance by 30% by date X. So that was one of the disappointing things in there. So I would say there's more to be done. It's a good start, but we can see hopefully some more policies to really put some flesh on the bones of that strategy. The sort of things we would like to see would be mandatory disclosure of residential buildings' energy performance. The governments have been talking about this for a long time, for really 20 years. We want to see that happening now. It should have happened 20 years ago. We need more regulations and incentives to really tackle improvements in existing buildings. There's a huge ticking time bomb there with our existing building stock. And the most vulnerable households in Australia would really need support, particularly given cost of living crisis right now. We'd like to see minimum rental standards put in place nationally. And there are some states doing that, the ACT notably, and Victoria here where I am, but other states and territories should follow suit. Finally, the last point there is saying, at the macro level, Australia needs to do better in terms of thinking about the demand side as much as it does in the supply side and how the two are integrated. I'll leave it there and answer any questions in the Q&A session. Thank you for allowing me the opportunity to present today.
Thanks very much, Jeremy. I think that's the first time I've ever heard someone speak on 2 times speed. That was that was quick.
I hope I didn't speak too fast as well. Sorry for anyone listening in who had trouble following.
It was clear for me, but yeah, no, that's good. Thank you. So that brings us to the first panel discussion. So I'll invite Daniel to come back, who will moderate, and our 3 companies are Fahrenheit, Orcan Energy, and EcoPhi. And I think, Jeremy, we haven't actually prepared any specific questions for you, but maybe you can stay anyway. And if there's any questions from the audience, then we can field them here. All right, perfect.
Just one question, because we're a bit behind the schedule. How long should we do? 15 minutes?
I would say we'll only have a 5-minute break, I think, anyway, after the panel. So currently we're a little over 20 behind. So I think stick with 20 minutes. So until 10 past 10, or a little over 10 past 10, just to give some good time for actually answering the questions. Yeah.
If you read the chat in between, if there's a question for Jeremy, just pop in and ask them, because I have noted some questions from the audience concerning the previous speeches, and then I have some questions also which I noted for myself for the companies. So just feel free to interrupt me if you find an interesting questions in the chat. Sure. I will be brief on the question which was posted to my presentation in the chat. There were several ones, and I summarized them in one major topic. Maybe this is Australia is not Germany. The heating market is not as big, of course, as in Germany, and therefore heat pumps are not maybe Australia is not the market for heat pumps like it is in Germany. That's of course clear and true. But underlying all these questions was a bit saying, well, it is like it is in Australia. We use coal a lot to heat our buildings because it's cheap, to produce our electricity because that's cheap. People like to live in big homes, 235 square meters per person. This is what we have in Australia, and that's how it is, and that's why we have to live with it. That was underlaying the questions a bit. Maybe I took it wrong, but this is what I read from it. And I can just answer, come on, is that really your opinion? I mean, of course, it is like it is, but we are here to change that. We should provide solutions and offers to these people to say we have to change, and this is also sexy to change. Of course, people want to live in big houses, but maybe we can offer different solutions. In Germany, we have the same problem. We're saving energy each year in the households, but we're using more and more space, so we don't save in the overall consumption at all. So we have to make the people live in smaller flats, and we can't make them by just having a law to do that. So we have to provide solutions which they want to have, and that's what I was trying to point out at the end of my presentation. Offer them something which is sexy, which is good, and there are solutions, and we all, politicians, we as a planner, the builders have, the companies have to work on that. So that is what I'd like to encourage you all to do. Not to say it is like it is, so we can't change anything, but to try to be creative, to try to find solutions for that, which makes the people want to have that. Okay, so that so much to the questions. I'm sorry if I don't answer all the questions because we want to get to the companies. And I would like to start with a question I have to Franka Kretschmer. Thanks for your presentation. I found it very interesting, and I think this is a great technology which you have. And I think this is something also which is very important for warmer countries like Australia, because we can talk about cooling grids, where you can not only provide the industry with cooling grids, but also district cooling with cooling refrigerants. So my question is, the first one, can your technology be used in residential and office buildings, or is it mainly the focus on industry?
No, it's also usable, and we also have some very interesting references. In Germany, there are some big buildings, also some residential buildings. We already supplied with our technology, especially in the combination with solar. It's very interesting because the solar thermal investment more or less can be used not just to make hot water or to support the heating system, also to provide the energy for cooling. So we can, I mean, when you see it as a total investment, this kind of energy you can use all over the year, and this is very interesting. And especially in the combination as a hybrid chiller, we can also provide the required cooling for ventilation systems, not just the ceiling ones. I mean, this is very efficient for our machines because the higher the cold temperature, the better the efficiency. But then with the hybrid chiller, we can also make these low temperatures to cool down the ventilation system. So there are some references if somebody is interested in to visit something in Germany, or also in Australia. We have some provided buildings. It's possible to give a contact or something. And it's just one sentence more. Where a heat grid is already given, especially in industrial context or in an area where you have heating systems, heating networks, we offer decentralized cooling systems. So we put just the machines and not make the cool centralized and make a network. So we put some machines, so we call it a virtual cooling net, so that you can put it there where it's needed, and where it's not needed, you don't have to supply by a network. Yeah.
Thank you. Then I switch to Jonas Fleischmann. Thanks for your presentation. It was very interesting. And I noted a question when I looked at your website, because I saw when you use the technology, you don't only produce electricity, but you also get warm water or warm air at the end as a process output. Can you use that? Because we were showing an example of a large manufacturer for concrete, but can you also use this technology to produce, on the one side, electricity for the company, and to use that additional energy which you get from your machines to feed it into a grid to heat buildings, for example?
Yeah, it's depending a little bit on the temperature requirement on the heating grid side. So also, let's say the delta T over our machines is on the taking the cooling water side, it's 20 Kelvin. So if you go in with 30 Kelvin, then you go 30 degrees Celsius, sorry, you will leave the machine with 50 degrees Celsius. So either you can then use a heat pump with this 50 degree to get it back to the 30, or maybe also combine it with an absorption chiller from Franka Kretschmer. I think it was 55 degree from the presentation. So this could also be an option to make it more optimized in that way. And I think it's also really interesting because I think the most cost or the highest cost in those industry projects is often decoupling the heat to some kind of network. And if this is done, you have multiple users. I think also in Jeremy's presentation, I was quite surprised that the heating demand for the buildings was rather high, which I did not expect. So then in winter times, you can use it for heating. Then in summer times, you can use it for generating electricity, maybe feeding also the Fahrenheit products with our electricity and provide cooling. So I think there are many options to be optimized, which we need to act now, right, and not tomorrow. So taking the first step and then going farther from that. Also thinking about new ways on how to combine technologies.
I think this is a very good subject to combine the technologies, because that makes the energy cheaper at the end. Whatever your output is, if you use it in multiple ways, you reduce the prices at the end for the consumer, and that is then maybe getting in the range of the low energy prices which we have in the moment in Australia concerning gas and coal. Okay, so then to Jonathan Kohlberg, also thanks to your presentation. And to be fair, I pose you the same question I had for the others. Is your technology also suitable for small projects, housing projects? Because of course you see a lot of options for industry, for large scale monitoring and so on. But would I, if I have a single household, would I also use, or would I be able to use your projects or your technology?
Yes, thanks for the question. To be honest, our big focus is on industrial system at the moment, of course. Technically, yes, this is possible. We also have our smallest solution, which was originally created for these small 5 kV solar systems. So this is technically also to be used in homes, I would say. Our big focus is on industrial systems. Regarding private households, I would say maybe in 6 to 12 months we're there. So we know that this is a big market as well, and we're working on it. But yeah, let's talk at the end of the year. To be honest.
We need to add that we had a question or several talks about electricity for cars and loading cars, which is of course also in Australia a good option, because there's a lot of sun, there's electrical cars, more and more electrical cars. So that would be an option for you too, to monitor this process or to steer this process of charging batteries of cars.
Yes, we're already doing this. We already have these EV chargers integrated, and also very complex algorithms, let's say, but also in the industrial context at the moment. Of course, this is in private homes, it's very interesting. In the industrial context, if you have a whole fleet of electric vehicles and the different chargers need to apply, or different rules need to apply to the different chargers, for example, because this one charger is only used by the boss, and this always needs to be loaded, and the other one shall feed into the grid according to the electricity prices. Of course, the reality is not as straightforward as the models and the theory. So we've developed quite a complex algorithm where you as a customer can define the rules for the EV charging more detailed than just charge it when it's cheap and feed into the grid when it's expensive, but to have more thorough rules for it, basically. So yeah, we're in this market. We started like a year ago to investigate more in this market and develop our solutions, and now we are quite confident to offer this in larger scale.
Perfect. I see a big market there in that area. Franka, a second question which I have: how efficient and expensive is your technology? Of course, this is always a question I guess you get every day, compared to conventional cooling. If you do it large scale, of course, is it comparable? Is it cheaper? Is it more expensive?
If it would be cheaper.
Sorry for this direct question, but I know people are going to ask that anyway.
Yeah. I totally agree. Of course, the technology is more expensive, especially because it's still in a kind of startup B series phase, I would say. There's not this kind of industry building these machines. I can give something like an idea of return of investment time. So if you run, and that's why we also focus in our normal business, we focus on industry when you have a running time of 8,000 hours. So you're in a production site and you have some compressed air systems providing heat in a stable way, and you provide CNC machines which are working with metal or something, then you can reach a return of investment times from 3 years. So it's kind of normal. But if you get slower, yeah, you just need the system 3 months a year, for example. It's getting higher, of course. So it depends also. I mean, this is a calculation for Germany. So this kind of return of investment calculation depends on energy prices. So this is something what needs to be calculated for the Australian market. I don't know what is the energy price in the moment per kilowatt hour in Australia. Is it similar to Germany, or is it much more?
Thomas, you can, or
residential
Jeremy.
I mean, residential prices around sort of 20 cents per kilowatt hour Australian. So what's that, like 15 euros?
Okay, so it's not that much away from what's here. And I mean, the cooling time in Australia is much longer than in Germany, so it also could be an idea to really calculate on the case, because it depends on different things. But the ROE could be 3 to 6, 7, 8 years, depends on how you use it. Is that
I think also here, yeah, thank you very much. And I think also here it's important, the bigger the project is, the more you integrate, the cheaper it becomes, of course. So think big is also, I guess, here a key, a solution.
Hey,
a last question to Jonas, because when I was following your presentation, you were saying, oh, I don't know if I got it from the website, that you use the ORC process instead of water steam. And I was asking myself, why do you do that? What is the advantage of using ORC?
Using an organic working fluid, they evaporate at lower temperatures. So if you think about your home and you want to start cooking water, it only evaporates from 100 degrees Celsius on without pressure. So if we would fill in the organic working fluid in that pot, you would not even need to turn on the heating plate to evaporate it. So it's already in vapor state at, I would say, regular conditions, so 20 degrees or something.
So it's a bit like in a normal heat pump, where you also have a different fluid which evaporates at a certain temperature, much below water.
Exactly. You can think about an OSC like a heat pump run in reverse. So it's the same process, only run in the other direction. So same working fluid group which we are using as in heat pumps.
Perfect. Thank you very much. Thomas, I take a look to your side. Did we get any questions which we would like to ask Jeremy?
Yes, so Jeremy got 2 questions. One he answered in the chat directly, but there's another one from Rayan Rashke. And they asked, what sort of options are we seeing for energy flexibility and demand management in commercial buildings? You're on mute, Jeremy.
Sorry about that. Options meaning policies, potentially to encourage that.
I suspect we're talking about technology, but Rayan, if you're listening, maybe you can quickly clarify, do you mean policy options or technology options? Both.
Both. Yeah, well, we have members, for example, in the EEC, we have Enelex is one of our members. who does demand flexibility with large industrial consumers of energy as well as commercial buildings. And they have, essentially similar to what you saw from EcoPhi, they have a box, a hardware solution as well, with lots of sensors and essentially that functions as a hub that takes in all the data, and then they're able to connect a bunch of different demand side technologies, and that could be chillers, it could be diesel generators that they have as backup generators that aren't always used, and then they can bid that into the flexibility markets that exist here in Australia. So that is one of the things I think that's maybe a little bit distinct about Australia, is that our electricity market does allow, only recently, the last few years, but you can now aggregate a lot of demand flexibility and bid that into the market as capacity or as generation during periods of high demand, when everyone turns on their air conditioners on a 38-degree day, and the energy market operators are worried about the grid collapsing, so they'll put the price up, and then people can respond by bidding in demand response and flexible demand. It's at the moment, I would say it's just a burgeoning, it's just starting, this market. It can be better, but even in the last round of the capacity investment scheme, which is a federal government scheme to encourage renewable capacity, we saw some large-scale demand flexibility projects successful in that scheme to get federal funding. And that's something that the EEC has been pushing for as well, lobbying on behalf of our members to make sure that demand flexibility is recognised in schemes like the capacity investment scheme. So we're not just building big wind turbines and solar farms, but we're also encouraging people to use the sources of flexible demand that they have sitting dormant in their existing operations. So that's, to answer your question, there are policies out there to support it. We think they can be tweaked to be better as well. And there are companies who are also aggregating demand flexibility.
Thanks for the answer. And Thomas, I guess it's time now. Time is up for the Q&A session. Should we stop here at this and make a short break and then continue in 5 minutes? What do you mean?
I think if there's any last question, we can take one more, and then we'll take a break from 6:15 to 6:20 Australia, and that's 10:15, 10:20 German time.
So I just read in the chat, the cost per kilowatt hour is 25 Australian cents on average, compared to 68 Australian cents for Germany. This may be accurate, but I'm certain it's much cheaper in Australia. Yeah, it is much cheaper, but it's not the correct figures. I pay here in my flat, I pay about 32 euro cents per kilowatt hour. So yeah, it's cheaper. But my question would be in your direction, or to Jeremy, how about the CO2 price for Australia? Is that going to rise? Or what is what are the politicians thinking about that?
Daniel, I actually wrote exactly that response to Cornelius's comment in the chat, that there is no carbon price in Australia. And I was around working in the federal government when we tried to bring one in 2009. We did have it for a while. It made a big difference. We can see the data that when we had the carbon price in place, emissions started to fall. But of course, it became one of the most politically charged issues we've ever seen in this country, and resulted in multiple prime ministers losing their jobs. And unfortunately, I don't see us bringing a carbon price back in anytime soon. So what we have in the meantime is the safeguard mechanism policy, which does have falling baselines, so that big emitters have to keep on improving their performance and reduce their emissions. But generally speaking, the electricity sector is kind of exempt from that. And we're just seeing that what's going to happen in the electricity sector here is that the coal-fired power plants will come to the end of their life by the 2030s, late 2030s. And when they retire, then they'll be replaced by renewables. But yeah, that's a slightly different situation here because of that lack of carbon price. It's one of the biggest lost opportunities we had in the last 15 years.
Okay. Yeah. So thank you very much to all the panelists for the Q&A session. So let's make a short break, 5 minutes, like you said, Thomas. and then we join at 20 past, I guess. And so I give back to you, Thomas.
Thanks. Thank you very much, Daniel, and thanks to Jeremy, and thanks to the panelists and companies just then. So yeah, 5-minute break. Jeremy, there is one more question there in the chat for you if you have a moment from Sven to answer that. But see you all shortly. Hello, everyone, and welcome back from a brief break. So, to kick off our second half of the symposium, I would like to invite Susanne Theumer from the Passivhaus Institute in Germany, and she will give a presentation about Passivhaus and NFIT standards. Susanne, are you there?
Yes, thank you, Thomas. I will share my screen now, and then I'll upload the presentation. Do you see the
Looks good.
the first slide? Thank you. So greetings to everyone from Darmstadt. My name is Susanne Theumer. I'm an architect, a certified Passivhaus consultant, energy efficiency expert according to the German government. I'm joining online from Darmstadt today with solutions, showcases for high efficiency buildings, building standards, the Passivhaus standard and the NFIT standard. NFIT being our standard for retrofits with Passivhaus components. As Jeremy said before, existing homes also in Australia lack energy efficiency, and we have a solution for it. So first, what is a Passivhaus? It focuses on high energy efficiency. The approach is to design buildings under the local context for high thermal comfort, but also for high indoor air quality, and to provide that with minimal energy input. So it's a performance-based standard, meaning that the maximum operational energy demand is clearly defined. So we are not just saying, like the European Union, that we have to be nearly zero energy, but then we don't give a number, but we actually calculate that and we have a clear number, and that number is 15 kilowatt hours per square meter in year, a square meter of treated floor area, so that's normally the living area. And either you are below that limiting value or you're above it. If you're below, if you use less energy, then you can get your building certified as a Passivhaus. And if you're a little bit higher, then you cannot or should not call your building a Passivhaus. So there are climate zone depending numbers. We have worked in the last 10 years a lot on the different approaches. All the Passivhauses look different in the different climates, but they have one thing in common. They can be comparable in their numbers because these are based on building physics. The buildings should ideally be optimized through design and operation to meet the targets. Then it's also very cost efficient. And obviously for warm or dominantly cooling climates, then we have also requirements for very low space cooling demands, including sensible and latent cooling. We have a Passivhaus database, including not only certified buildings, but also, but they are marked certified buildings, and also under which certification scheme they are certified. If it's a Passivhaus, if it's a NFIT, then it would, instead of be 15 kilowatt hours per square meter in year, it would be 25, or they use a component method. I come to that later. Then there are PHI low energy buildings for those that nearly, they want to achieve Passivhaus, but they are near misses. And there are also pilot projects that have adopted a few Passivhaus components, or they are the first supermarket or hospital, but they are pilot projects, so we haven't yet defined clear target values, for example. In the center right picture, we can see a non-residential project from Sri Lanka, and that's also a retrofit. But I invite you to have a look at this database, because you can also find projects there from Australia and New Zealand. In this slide, we see the first certified Passivhaus in Darmstadt from 1991. And what is clear from the graph at the bottom is that they are that it's a durable standard, that we can show that over the last more than 30 years the numbers have been continuously low, as we wanted it, as we also expected it. And this is due to quality assurance during the design phase, but also during the construction phase. For that, we need ideally trained people, trained professionals, could be certified Passivhaus designers. We provide course modules since 2009 approximately. And then we have course providers all over the world giving courses for certified Passivhaus designers. And later on, we also developed for the workers. So we have a certified Passivhaus tradesperson module. And we trained 25,000 people in these years. The numbers were presented this weekend at the 27th International Passivhaus Conference in Innsbruck, Austria. But we cannot stop there. Our partners in the UK presented last year there were their first talks, and now this year they presented that they are introducing Passivhaus e-learning modules in all the universities for the first year in university for architectural students in the UK. That would mean, if that's fully implemented, 15,000 architectural students a year. And from the 65 universities that have signed the letter of intent, now they work with 23 already, and they follow up on the other ones. And now they are gonna expand this training to other target groups, such as engineer students, etc. So this Passivhaus standard started with a single family house or 4 housing units, but it's also for, as I showed, for non-residential, even for high-rise buildings, entire districts, such as the Bahnstadt in Heidelberg. It's a larger district than the city center of Heidelberg. And also China is gladly copying the Passivhaus standard and is building entire cities, new cities in the Passivhaus standard. It's a voluntary standard, but building certification ensures the high quality is actually met in practice. So this is state-of-the-art high energy efficiency for buildings. It's one solution that we can prove and test that it's working. Obviously, code and policy should push to high energy efficiency. This would really be very helpful. So we all have to work together also in terms of changing the policy and introducing incentives. We calculate to get those numbers and be able to compare the numbers. We calculate with our Passivhaus planning package. It's an Excel-based tool from 1996. So we have the true and the honest numbers. So we can say, look at these existing buildings. Here we have a very high heating energy demand. Jeremy said that also in Australia, it's dominantly at the moment the heating demand that we should address. But the good news is that once you insulate your building, fabric first approach, then you also automatically reduce the cooling demand. So we have shown that we can improve 90% by those passive house components and these measures, and maybe around 60% for the cooling. We apply the 5 basic passive house principles, continuous layer of insulation. Sometimes we, in warm or cooling dominated climates, we do not insulate the floor slab, but the PHBP tells the designer from the early stages if it's beneficial to insulate the floor slab or not. Then passive house windows and external shading devices, ideally external shading devices, but you can calculate in PHBP also how little influence or impact internal shading would have, and then you decide for the client or together with the client the best solution for this individual, for each individual situation. We also need one continuous air tightness layer to prevent drafts and moisture problems, and a ventilation unit with heat or humidity recovery, or so-called energy recovery. So we provide fresh air. There's filters. I think it was already mentioned before by Daniel. And we try to have no thermal bridges, so no weak points in the construction. But also if there are a few thermal bridges, we try to reduce those so they have very little impact in the energy balance. Because what we also see with the PHBP, it's a whole house approach and everything has an impact. So all the energy that comes in and all the energy that goes out, if you change the thermal quality of the windows, we will hear the presentation just after my presentation about windows. That will have a huge impact, because windows do not only bring in light and solar energy, but they also have losses, higher losses than an opaque wall. One of the benefits for hot climates is that in existing buildings we have peaks during summer, and that can cause problems. And in passive houses and NFIT renovations, we reduce the cooling loads, so there's no cooling peak power problem, which we all benefit from. To promote the combination of fabric first, but then adding also renewables, either on-site or new renewable plants like wind turbines or whatever it might be, but new, not on site, but also in a different country even. We have introduced new classes. Passive House Classic was the standard we had since the beginning, since 1991. But now we have Passive House Plus and Passive House Premium, where we also calculate not only the renewable energy generation, but also including the storage losses from storing or having to store energy, surplus energy, ideally renewable from the summer, to use it in winter. And we heard before about from the chat from Cornelius Chitlow that they are currently also talking or building even one of the largest gas fields in the world. So it's not about the different, gas is a problem, we all know that, but it's the main issue is what we burn. So if we switch from gas to electricity, but we do not insulate our home, so we don't reduce the energy demand, then we need a lot of electricity, and that is we need to introduce the energy efficiency. There's no way around it. We have also limited supply of renewables, and we have a lot for the energy transition to provide the electricity for. So we need the electricity, not only the renewable electricity, not only for our buildings, but also for the transportation and industry sector. So it's a good choice, and it's also a very cost-efficient choice to follow the fabric first approach. So now talk a little bit about Enefit, our standard for the renovation with Passivhaus components. The components are the same components we use in new construction in passive houses, climate dependent. And we also certify components to ensure that that it's easier for the architects to choose. So they have all the qualities, they have all the values, and the list of certified components is also in PHPP in the tool. So you can select from those, and you know that they are high quality. I show you some examples from the early days. So this is in Frankfurt from 2005. It's a social housing with a very, these are the thermal images, very high heat loss before the renovation and high energy consumption, which could then be reduced. We monitored the building also, and it's nearly passive house. And that is due to the great compactness of the building. But that is not even necessary. If you are below 25, it would be a super energy efficient buildings. You have all the advantages of the passive house. Even if you're a bit higher in existing buildings, it's often not possible to go with reasonable effort down to the 15 kilowatt hours, because the buildings are not optimized. They are not in the perfect orientation and so on. And the window sizes maybe also not everything optimized. The Enefit standard is very flexible. So we have energy demand method below 25. You can tick the box, or you go component by component. We have also introduced, we said this at this International Passivhaus Conference of this year, new certification schemes. So there's not only Enefit, there's also Enefit unit. Before we only certified entire buildings. Now we certify also apartments, individual apartments. If the building or the apartment owners in a big block, they do not agree on external measures, then everybody can also do whatever they can from the inside of their apartment and make that energy efficient, and we give them a certificate for that. And also for office units, it could be, or retail units is could be certified under this new scheme. And here we see a Passivhaus Plus renovation in Cologne in Germany. This is something quite new in the last years. It's still expensive, so these are pilot projects. It's a serial renovation, so whole facade elements, sometimes equipped with the windows already and the ventilation system, are brought to the old house, and then in a few days or weeks the building is retrofitted. The architect was also awarded the Passivhaus Plus certificate at this weekend at the 27th International Passivhaus Conference, and they are gonna build an entire district in Cologne, retrofit an entire district in this way. Here, those balconies that we see, they were put into place. They are prefabricated as well. So instead of having the old balconies slab, like a huge thermal bridge, we put additional space, like bigger balconies than the existing ones, and we place them in front of the buildings, so the loads are carried directly down, and there are only a few connections, fixings needed to avoid that they fall down, and this is minimized thermal bridging. And here another project from Madrid. It's a traditional certified EnerFit renovation in the traditional construction system. So not prefabricated, but also a very nice project. You can find out more in our database. And here is a design pH model that is a 3D plugin for SketchUp, where you can directly see the and optimize the buildings at the early stages, because this is where the cost factor or the cost savings are largest. We have also a network, the International Passivhaus Association, where we have more than 6,000 members. And this Australia is also part, and New Zealand also is also part of this network. So I invite you to get in touch with the Australian Passivhaus Association and join forces. We are connected globally, but we need local solutions, and we need to work together. We have to spread the word. It's so important to do and not just to talk about energy efficiency. But first we have to train our own people, but then also our environment. Thank you very much for your attention, and I'm happy to answer any questions that you might have now or also later in the Q&A. Thank you.
Thank you, Susanne. What we'll do is we'll have the questions a bit later in the Q&A. We'll do the same way with Jeremy. Excellent. That was a really impressive thermal imaging there. That really kind of drives it home. You see the building completely different color with the thermal imaging. So yeah, really interesting stuff. So now we'll have 4 presentations from our next 4 companies. Some of them which have quite a lot of relevance to the presentation that we just saw. And the first one of those is from a company called Energate, who make high-performance wood aluminium windows and doors. And the presentation will be from Ludwig Matthias Hausler, who is the manager there. And he already has his presentation up.
Yeah, thank you, Thomas, for introducing us. Thank you, Susanne, for speaking about the Passivhaus technologies. And do you see my?
It's just in notes mode, or not in presentation mode, so we can see everything else.
Do we have a presentation mode now?
Not yet, no.
On my screen it is.
Maybe if you try unsharing and sharing again the different window.
Let's try this.
That's better. Yep.
Yeah. Okay. Yeah. So hello everybody, and thank you very much for attending our conference and this presentation. I want to talk today about energy efficient windows and doors. I want to start with this picture. That's the Center for Green Buildings and Cities in Harvard. You can see on the right side a manual version of wood aluminium window on the lower part, and on the upper part you see automized motorized unit which is connected to a house system, so the ventilation of the window is integrated into the complete house system. So my name is Ludwig Matthias Häusler, and we are running a family-based company since already 6 generations. We are having for glazing business. We are since 4 generations in the windows and doors business. My father has been sent from my grandfather into a consortium to develop the wood aluminium system itself in Germany. So we are into this very long time. There is some projects which I wanted to share, just the different possibilities, what windows can do. Those projects for retrofitting on the lower right part. This is a Hambacher Schloss, symbol for democracy in Germany. I think everybody who works in the cars in the Chamber of Commerce knows this. And we are coming out of a 2000-year-old city. On the down the left part, that's the city center of Speyer. The technology we are doing is an award-winning technology. Our Energate system has been utilized in solar decathlon winning projects. We participated in the 2007 and 2009 winning teams. We used a symbiosis out of architectural design and energy efficiency to make all this happen. Our government and was very happy and visited us. So Angela Merkel was coming and she said a house that uses less energy than the products is the right answer to many questions of the future. That's what we are doing when we produce each element. We focus on the energy efficiency, on the durability, and we work in engineering and we help in the implementation. Our products are coming from wood aluminium windows. We have several product lines, also entrance doors, sliding doors, different combined elements. All of them are available in the highest standards. I wanted to share here the projects on this screen with you. On the top left, you see that's the first certified Passivhaus project in dry and hot desert climates in Saudi Arabia. We have been working on a lot of details, and I am sure for some parts when it's very, very, very hot in Australia too, those are very interesting for your market too. And the products which we are doing in Energate are not just European products which are exported. They are specifically made for the target market, and I'm mentioning this because it's a very big difference in terms of colors, in terms of durability, in terms of resistance to the sea, what is the normal European and German standard, and what's required to a specific environment where you have a very high UV radiation. And in Energate, we have this declinated for many, many years and decades, I can say, and we have lots of experience in this, and the products are especially made for that. On the lower part, you see a refurbishing project. This is a renovated house. It was done from the Harvard Center of Green Buildings and Cities. And on the right side, you see, Susanne mentioned it before, China has also been involved in making lots of passive houses. We were chosen to make the first passive house ever built in China together with the Deutsche Energieagentur and worked with the ministries there on the prototypes. And now there's a book existing with over 150 pages of Chinese and German, how all this technology works. That's the headquarters of the International Renewable Energy Agency. It's the master city. Lots of conferences are hosted out there. We've had the honor to work with them too and help them to save energy, optimizing their facades and window details. And there it has been slitted so the balconies are having the function to bring shade back on the wall insulation and window layers, and it's very nice architectural detail and very good living working quality in there. That's basically what we are doing. We produce, we pack, and we ship high performance windows and doors. There you can see it a little bit. We produce on several production sites. We bring them to our central loading and packaging place. And there we load the containers and everything is transported to the place and then it arrives. And the big difference is that when we bring things, that everything is lacquered out of one automatic machine. This means from the fixed frame to the entrance door, to the side entrance, to the slider, to the combination of the small facade, everything comes out of one design, one selected wood, one color. And on the outside, the same. Aluminums are powder coated, they are welded in the corners, they're very airtight. So in the end, the work is very beautiful, and we are specialized on bringing them without getting scratched in a safe manner to any place in the world. And when we work together in projects, as soon as the building permission is given, then when we work together in this team, before the building permission with the details and everything is set, and when the order is placed, then usually the windows are quicker on the site than they are needed. So here in the middle, you see a picture where the windows are waiting to be needed because the rest of the building needs to be still built. Yeah, that's a little bit from what we are doing. If anyone's interested in this and collaborating and working together, we are specialized either on one family houses, on small renovations, or on larger scale projects. And also we sometimes help in bringing in goods which are maybe needed or wanted from other places out of Europe and bring them in containers. So if we make a one family house and there is some space in the container, it's not unusual that we help the clients if they want some additional things. And we have examples where we bring staircases or we bring other stuffs to optimize load and save energy on transportations. So I want to thank you for your attention with this, and I'm ready for any projects afterwards or any contact, any questions. Thank you very much.
Thanks very much, Ludwig. Nice to see a real long family history with the company. That's it's very hallmark of some of the German companies we deal with. And join us a bit later for questions as well in the panel. So next I'd like to welcome James DeSalis. He's actually based in Australia in this case, but he's a business development manager and engineering lead for Lunos.
All right, great. Can you hear me there? And I'll just share my screen as well.
Yeah, can hear you, can see you, but no presentation yet.
Share that, and then how about that?
Yeah, perfect.
Great. All right. Well, thank you, everybody, for joining in, and thanks again for the great presentations. My name is James, and I am the Business Development Manager here at Laros Technologies. We're the distributor for Lunos here into Australia, and so I'm going to be presenting on the Lunos ventilation systems. So a little bit about us. We've been providing ventilation systems to Australia for the last 10 years, and we've partnered with Lunos to bring in the Lunos ventilation range of decentralized systems. Lunos is founded in Berlin in 1959, so quite a long time ago, 60 years of Lunos, which is a long time to be producing ventilation systems. At the present time, they're just over 110 people working at Lunos, and they've been the market leader for decentralized ventilation systems for at least the last decade or so. And so there are quite a few German manufacturing advantages. There's quite a lot of ventilation systems available around the world. And so the German manufacturing advantage is well known. I won't hammer on about it, but essentially made in Germany, higher efficiency, higher streamlining, and being put together in the German factories mean they have a much higher control over the production lines as well, meaning that the all of the components for all the ventilation systems are all available locally and then can be brought to us all as one package. Distributing around the world to all sorts of distributors, us here in Australia, bringing these units in and supplying them to Australia and to the Australian market. We're based in Canberra, so based in a cold climate. We do have higher need for ventilation than the rest of Australia. And we also supply the full range of the Lunos products. So there was an introductory presentation on what ventilation systems are and why you would use them. But the Lunos product range is a decentralized ventilation system range, focusing on a few different products that can be applied both in retrofit situations and also in new builds. The units are small, easy to install, and can be distributed around the building, meaning that there's no need for large ducting systems, and they are able to provide fresh air with heat recovery and filtration to the building while extracting stale air, humidity, and excess pollutants from the internal environment. The E2 system is the central component of the Lunos ventilation system. It's a push-pull ventilation system, as was mentioned in the first keynote. Can be installed straight through a wall and has a large ceramic heat exchanger, which is, I guess, essentially a brick with a lot of holes in it. There's a lot of thermal mass and a lot of surface area. And as the unit pushes air out of the building, extracting pollutants and high humidity levels, it then collects the warmth on that ceramic core, and after a period of time, it reverses directions and brings the warmth back into the building while bringing fresh air in from the outside environment, including filtration on that fresh air as well. And this is particularly needed as the Australian building industry moves towards a more energy efficient building mentality, essentially, to reduce the amount of energy consumption in the building. The lowest hanging fruit is airtightness of the buildings. And as it's being increased, as the airtightness level is increasing over time, the indoor air quality is decreasing. And so these products can be easily installed to provide fresh air for addressing those issues. Then, of course, the newest product line is the E2. The improvement on the E2 is the E260, which provides twice as much airflow, as well as higher efficiency for decentralized ventilation system installation. There's also the Lunos Next product, which provides fresh air in a continuous manner. It's not a push-pull system. It's actually a miniaturized counterflow heat exchanger or cross-flow heat exchanger in the center of the unit, and is also a wall-mounted unit. And so we've had quite a lot of experience here in Australia with this being an easier add-on than a full ducted ventilation system, and obviously a lot cheaper. It's particularly suited to living areas for apartments or open plan kitchen, living, dining areas where the air tightness level has been improved to the point where potentially there's a decrease in the indoor air quality, high relative humidity or high VOCs, smells, and then these units can be installed in those situations, which would provide you with an increase in air quality. And finally, the Lunamat, which is a Passivhaus certified component released very recently, a couple of years ago by Lunos. The miniature ducted system allows it to have a small amount of ducting running through a building, which is suitable for, say, bathrooms or kitchen areas where you need to extract high humidity and send it outside as per the building code here in Australia, but you do want to harvest that energy that's in that outgoing air. And so the Lunamat is certainly appropriate for that, and also allows you to have Passivhaus certification if you are pursuing a particularly high efficiency building as well. The real advantage of the Lunos system is because Lunos has been working in this space for so long, they have a full combination of different ventilation options, with the ventilation provided into bedrooms and studies, small living spaces by the E2 or E260 system, and then larger systems like the Next or the Lunamat being suitable for larger ventilated areas in the home, or also I didn't mention in this for brevity, but there's also a range of extraction fans, the Silvento extraction fans, which are for suitable for replacement as standard extraction fans here in Australia. And the advantage of the hybrid ventilation system is that it can be a whole of house or a whole of apartment ventilation system, and it does directly address the new building code requirements here in Australia, 2022, in particularly section H6V3. I can answer any questions about that later on, regarding the amount of fresh air that's required if a building is sealed to a certain level. A few references. Obviously, Lunos provided ventilation systems for the largest project here in Berlin, and then around the world in Italy as well. But we have a few here in Australia that we're very proud of, and we're looking to increase the reach here in Australia. But there's some university dorms that have 220 Nexts installed at the university dorms there in Melbourne. There's quite a few schools with the Lunos Next unit installed as a ventilation system for a school building, targeting higher efficiency or passive house, but requiring higher amounts of fresh air, being a classroom environment. Also apartments, particularly here in Canberra, but also in Melbourne, there's a push for apartment buildings to be more well sealed and to have associated ventilation systems for higher indoor air quality. And so we have a few projects that we can talk about there as well. If you have any questions about specific projects, suitable for large houses as well and small houses. Obviously, if it works for apartments, it will work for houses. Here's a nice, particularly good one in Portugal. And we have some examples. We have about 400 systems operational in Australia at the moment. We're looking to grow that number. And so feel free to reach out and make contact with us at the contacts earlier. Thank you very much.
Thank you very much, James. And yeah, we'll be catching up with you again shortly in the panel for some questions. And so then we'll quickly move along to welcome Thomas van Ramsdonk, who is the Chief Executive Officer for ProClima Australia and New Zealand. Thanks, Thomas.
Thanks, another Thomas. It's not that often that we find another Thomas on this side. Can you see my screen?
Yeah, looks good. All good.
Awesome. Well, it is a challenge in terms of many presentations and getting well underway. So thank you everyone who has presented already, and there's a few more. And seeing Helen there on screen as well, I just want to do a shout out to the Green Building Council of Australia, because they're driving some great change that's happening. And I just want to pick up on what James was talking about. So we are as Proclama, we're a manufacturer of membranes and tapes. That's all we do. We only do a millimeter on the outside and do a millimeter on the inside in terms of products, but that's not the main thing I'm going to talk about today, because what we really talk about is what James mentioned, indoor air quality. And this is a great quote I always bring up from Schopenhauer, that health is not everything, but without health, everything is nothing. And we all know that when the man flu strikes, we are down, the world comes to an end. So health is really what drives a lot of decisions. Where did we come from? We're not as old as some of the other companies presented. We started in the late mid-80s as an ecological building material merchant in Germany. So we have some original products and then some high performance products that came in during the progression of Proclama. Modern Proclama, we are in Australia for quite a few years, and I think in the meeting chat there was a few reference already to large-scale houses. So this is a 1,000 square meter home in Australia, a little house down the road, fully covered in weather tightness barriers. This is the internal air tightness and moisture control. That's a link also to what I was saying with the Green Building Council of Australia, talking about air tightness and blower door testing. I will show that in a minute. This is a very special project that we got involved, which is the Australian National Library. Was re-roofing, a very challenging building, but yeah, been absolute privilege to be part of this commercial work. And also what happens more and more is modular construction. So these are actually pods manufactured in Vietnam and then shipped out to Australia. And we're actually working with the manufacturers locally to ensure that also code compliant products get into the country. That's another hot topic. What is the Proclama way? Well, the Proclama way is actually to educate. So what we found is that we really need to provide more background information to people, for people, why they should do certain things. We talked about Passivhaus. Passivhaus is an energy efficiency standard that is over 30 years old. We are very lucky that we do have some certified passive houses already in Australia, but we also need to make sure that we don't create perverse outcomes, what we have seen in other jurisdictions around the globe by what James was saying, sealing up, not understanding heat and moisture flow through construction. So this is a 260-page document that we wrote for Australia that highlights all the issues that we already have and what we should provide, what we should prevent going forward. So anyone who's interested, just hop onto the proclama.com.au website and you find a link to the study you can download. If you want to have a hard copy, we also have hard copies available. It's a beautiful read for a Sunday evening if you can't fall asleep. I guarantee you after 20 pages, you are sound asleep, because I have not met anyone who read it cover to cover. Going back, it is about the health. As I said, one of the key things is that before we build, we want to make sure we do proper simulations. So from our end, we have a bit of unusual situation that we are actually a cooperation partner of the Fraunhofer Institute for Building Physics, in particular the Institute in Holzkirchen, where Hartwig Kunze developed this software simulation tool. So it allows you to simulate the heat and moisture flow through construction, and based on real climate data and real material data. And this is what I was talking about before, and I was a bit flabbergasted when Jeremy was talking about no specific targets again, no teeth in the documents coming from the Australian government, because what would have been super easy is just to introduce some air tightness targets that we can easily verify through running a blower door test. If you have not participated or seen a blower door test, it's always, you can always see this on grand designs in particular. When a technician shows up, the builder runs for the hills, the homeowners are scared. That's normally the blower door part. It is a fun exercise. It is normally something that we do together. So if anyone who's currently here in the audience would like to actually participate in a blower door test, again, get in contact with us. You can give us a call on 1-800-PROCLAMA, or just hop on to the website proclama.com.au, and we're happy to answer any technical questions, because we are technically and technology-driven company in Australia as a country. So thank you very much. Back to you, the other Thomas.
Thank you, other Thomas. You stuck to your word. You did that in 4 minutes, so very impressive. And thanks for the quote at the beginning. That's quite interesting. All right, so yeah, here we go. Our final company presentation, which is Engelmann Sensor, and I believe would it be Benedict that will be presenting.
Right. Hello, everybody. So first of all, thanks to the Chamber of Commerce. Thanks to Thomas for setting all this up. very nice presentation. I hope you can see mine as well.
Yes, we can. Yes.
Great. So my name is Benedict. I have the pleasure to walk you through why Engelmann is doing what we are. And if I start with that, I might start with looking into the question of why are we saving energy at all? So what's the purpose of all that? Let me just see if I can get that to a larger screen.
I think there's a button on the right-hand side above the two. That'll, yeah.
Here we go. Thank you. So maybe one information up front. A human being has a CO2 footprint of approximately 8.5, maybe 9 tons per year, whereas 40% out of that is actually accounts for thermal comfort. So be that cooling or heating, so thermal comfort that you would have within buildings. And what we see through climate change is that, well, climate is getting more and more severe. I think Susanne said it this morning. It's not quite normal that on the 7th of April in Germany, you have 29 degrees Celsius. So more and more people are looking into having access to either having cooling systems or heating systems. Interesting information that I learned today already was that Victoria also having quite cold days, so therefore is a lot of need for heating also in Australia, whereas my first perception was we're mainly talking about cooling systems. Still, the question or the point is that buildings more and more are using heating or cooling systems. And then there's different kinds of systems which would be applied. I think it was Daniel this morning saying also that this project in Belgrade, I think it was, so super new building, fancy area, quite luxurious. And then there was this split electricity air conditioning systems, having some side effects also, because that would create what is called heat urban island. So the warm thermal energy that is being absorbed by the environment in this area, although having a new development of buildings. So there's a couple of questions about the why thermal energy should be reduced at all or saved at all. One is about the environmental aspects, of course, which just shows what the carbon footprints of buildings are, and then also of the human beings. But also there might be some rules and regulations which are being set up in different areas of the world where you should just comply with, which exists already. We have that in Germany, for instance. There's a Heat Cost Act, which exists since the early 80s. So it is mandatory to monitor thermal energy. Water also, by the way, water is a topic which is quite usual for the world. Everybody looks at water consumption and individual water consumption also to make sure that water can be saved. For thermal energy, it is coming up, let's say, at a slower pace. I'm sure we will be talking also for the Australian market about incentives that are given by the government when we look at different energy efficiency levels of buildings. So if you take LEED statuses, for example, which at the end could drive a profitability of a building because you are living at a higher standard. Overall, what we are seeing when we look into cost savings that are possible by measurement of thermal energy, we're looking at an average, and that's, well, actually it's at the lower end of 15% of energy cost, which can be translated into CO2 footprint reduction also by monitoring thermal energy. So that would bring us to what we are basically doing. Our product, which we are producing since almost 50 years. So for German standards, a rather new company. I wouldn't say startup anymore, but still rather new, is that we manufacture BTU meters, thermal energy meters, which can be used in hydronic systems, so water-based systems, for heating applications and cooling applications. What we basically do is we measure the temperature on the inlet side and the outlet side of centralized cooling or heating system. with temperature sensors, and we also measure the flow. And having these two informations, so the delta T from the inlet and the outlet side, plus the flow of water that is being used for heating or for cooling, we are able to determine how much thermal energy was spent in this specific application. So you can bring that down to an individual user. You can bring that down maybe on industrial scale or commercial buildings to a cost center, to an office space, maybe to one floor that should be monitored. And that gives you transparency about what is being consumed in this area. There's a couple of different businesses that can be created based on that. All is created on this data, which is provided by the meters. So what is used and done in Germany big time is that there's consumption-based billing. So all tenants and users pay for what they are using. But of course, you can also use this information, for instance, to monitor the energy efficiency of a building or of a department or of a certain area of a building. You can compare that with other buildings and share this transparency with the users in that building, or use that as an energy saving company to bring up potential ideas how to optimize systems, how to optimize the hydraulics in a building. Or for example, also something Daniel shared this morning, looking into the efficiency of a cooling or a heating system. For example, looking into the efficiency of a heat pump. So like I can say, like many German companies also, we can say that for thermal energy meters, we are the largest manufacturer of the world, although we're a rather small company, having 160 people here where we are close to Heidelberg. So we have manufactured more than 10 million of these BTU meters meanwhile, and growing numbers. We see that the demands are really increasing. And our portfolio not only consists of the heat or cooling meters itself, but also of water meters, and then also readout and transmission technology. So we have a gateway that basically collects all the data from the meters and transfers them to the cloud, let's say, to make it more general. One thing that is very important for us is we design our products for to remanufacturing. So we're actually recycling our products also, and this is why also the Australian market is quite interesting for us, because we have learned that until 2030, 80% of the energy in Australia should come from green energy, from renewable resources. And what we actually do by having this approach of design to remanufacturing is that we are able to reduce the carbon footprint of our products by more than 80%. Also, we are already able to do that. So would be looking forward to the discussion throughout this week to find potential partners for Australia, which is, you can see that on the map, not red, that's our company's color, not red yet. We would like to find a partner to jointly develop the Australian market. So that's it from my side. Thank you very much. Looking forward to your questions.
Thanks very much, Benedict, and we'll be with you again shortly after the next presentation, which is a presentation from our second Australian expert, and that's Helen Bell. She is the Senior Manager for Research at the Green Building Council of Australia, and she is also involved with the World Building Council as a research manager too. So she will talk to us now about, I don't have the title of your presentation, but you'll show us in a moment. Thanks, Helen.
I will indeed. Thanks, Thomas. Just get rid of that and get my speaking notes up. Sorry. Share screen. Sorry, just a moment. In order. And sharing. Great. I actually do this a lot, believe it or not. So sorry that took me so long. But hi, everyone, and thanks for the opportunity to be part of the Energy Solutions Symposium. It's fantastic to have you all so interested in energy efficiency, because that's a really big component of what we do at the GBCA. My role is managing the research. I'm in the research and policy team at the Green Building Council of Australia. And in my role, I look after the research that underpins a lot of the work and the sustainable transformation of the built environment. Today, I'm going to provide you a bit of an overview of what the GBCA is and does, as well as the Green Star Buildings rating tool, and I'll touch on Green Star Homes as well, because I think we've got quite a mix of residential and commercial people in the audience today. We'll look at what's happened in energy policy and what we'd like to see happen. And then I'm just going to highlight the need for green interactive buildings and some of the work that we've done in that space. Thomas will share my presentation following this, so hopefully if I'm speaking too quickly, that won't be a problem. But the GBCA is Australia's leading authority on the sustainable built environment, and since our launch in 2002, our purpose is to lead that sustainable transformation. And next slide. Our work is framed through 4 key pillars. We rate, page up, sorry. We rate sustainability of buildings, fit outs and communities using the Green Star, which is Australia's largest holistic voluntary rating system. It's very similar to DGNB in Germany. Sorry, my slides are all over the place. We educate through forums like this, but also educate industry practitioners and decision makers promoting green building programs, technologies, design practices and operations. We advocate for policies and programs that support our vision and purpose, and we collaborate. So everything we do is done in really close collaboration with our 650 plus members. And they're really our key enablers, supporting us to achieve our strategic objectives. Members span the whole built environment, from academia, government, industry. And in today's audience, we've got a few present. So I'd just like to thank Arup, Jacobs, Viridis, and the University of Sydney. We also collaborate with the Energy Efficiency Council, as well as with Race for 2030, who we've got here today too. As leading providers of energy efficient solutions, you're all really aware that people are expecting more from our buildings. Owners, investors and tenants expect healthy buildings. Australian investors are putting climate aligned targets in place. Most of our top 100 companies listed on the Australian Stock Exchange report now on social risk. And our government's legislated a 43% reduction in emissions by 2030. So Green Star supporting this sustainability at scale. We've now got over 4,500 Green Star certifications in the market, and it's designed so that you can take action now, because in the design of your buildings, you're designing the buildings that are going to be standing for the next 50 years, as we've already heard today. So there are 5 Green Star rating tools. Covering all stages for design, construction and operation of buildings, as well as building fit outs, communities and homes. I'll touch on Green Star Homes, picking up some of the areas identified as essential in by the Passivhaus Institute, which Susanne's already spoken about earlier today. But I'll focus mostly on Green Star Buildings, and that's our rating tool for new buildings and major refurbishments in the commercial market, as well as in apartment buildings. So the Green Star Home Standard, this was launched in 2021. It's really aimed at volume home builders in the Australian market, and it provides healthy, resilient and energy efficient homes powered by renewables for all Australians. So picking up on Daniel's presentation earlier, when we took Green Star Homes to the market promoting the benefits, promoting the benefits to the homeowner, not the benefits of mitigating climate change. So a healthy home is one that's got to be built to be well ventilated, very topical on today's discussion, which in Australia means really preventing the growth of mold. It's got to be built to minimise the entry of pollution such as bushfire smoke. It's got to be thermally comfortable and uses materials that are low or non-toxic with high quality lighting. I won't go into the specifics of what's in the Green Star Home Standard, but we cover, for the ones of most interest to this group would be air quality, moisture management, heat resilience, and then it's got requirements for thermal performance, window systems, we require double glazing, air tightness, energy efficient appliances, as well as user guides to teach people how to use all that tech. But Green Star Buildings, this is our tool for the commercial market, as well as for apartments. And we rate Green Star Buildings with 4, 5, or 6 stars. So from Australian best practice through to world leadership. 1, 2, and 3 stars correlate to the national minimum standards and national construction code would be a 1, average practice and good practice. We don't give you a Green Star rating if you're only average to good. So we're really working at the top end of the market with the rating tool. The tool's made up of a number of categories, and teams need to achieve minimum requirements in each category to achieve the rating, ensuring the delivery of a holistically sustainable building. And again, you'll get these slides. While the 8 categories are all really interconnected, it's the positive category that encourages carbon reduction through operational energy efficiency, as well as reducing the embodied carbon within materials. Specifically, we reward the use of low carbon design and materials, while with energy efficiency design, reducing operational costs, as well as reducing the reliance on the electricity grid, which is a really big one in the Australian market. Assets using Green Star Buildings must be highly energy efficient, fossil fuel free, powered by renewables, and built with lower upfront emissions. And after reducing all greenhouse gas emissions as much as possible, any remaining Scope 1 emissions must be offset. And we also expect our buildings to be grid responsive. We've created a climate positive pathway, which you can see in really small print at the bottom there, where it says 20% more efficient. The kind of, oh yeah, it's highlighted in the bottom. The pathway requires a much bigger reduction. So a 20% improvement on the National Construction Code in terms of energy efficiency, 20% less embodied carbon in materials, and all of your Scope 1 and 2 emissions have to be offset. So all 6-star Green Star rated buildings must follow that pathway, and anything registered from January 1 last year onwards for 5-star has to follow it. And from 2026 onwards, 4-star rated buildings will have to follow that climate positive pathway too. We need the pathway in place so we can get our buildings on a trajectory for the Paris Agreement, because buildings we build now are going to be the ones standing in 20 years' time. Our federal government's also announced that from July 2026 onwards, it'll only occupy buildings that achieve at least a 4-star Green Star Buildings rating following the climate positive pathway, which brings us rather neatly to our advocacy program. So in 2023, we worked with Jeremy's team at the Energy Efficiency Council, as well as others, to deliver our Every Building Counts report, setting out our policy recommendations and providing a roadmap for governments towards greener, healthier, and a more equitable built environment. The report highlighted that 64 million metric tonnes of carbon emissions can be avoided if we develop a consistent plan to improve the energy efficiency of our buildings across all 3 levels of government. Now, key goals in the Green Star Buildings are energy reduction and decarbonising, and our Every Building Counts policy papers focus on those same goals. There are 8 policy themes, which you can see here, and they're all focused squarely on energy and carbon reductions. This work's resulted in a set of recommendations covering residential, commercial, and public buildings that are ready for implementation by our government. And among the recommendations is a call for Australian homes to be given energy performance ratings, which has already come up in the chat today, similar to those on white goods and electrical appliances. And yes, we think it can be done. The government's already released a paper on looking into the feasibility of it. The Commonwealth Government has. We're also calling for new residential and commercial buildings to be delivered as all electric, as well as phasing out fossil fuels in existing buildings, which will see the end of gas water heaters and cooktops. The report recommends energy market reforms to elevate the importance of taking demand side action. We need our buildings to be demand responsive and able to interact with the electricity grid, which brings us to our work on grid interactive efficient buildings. So our 2023 paper highlights the crucial role of grid interactive buildings will play in achieving a zero carbon future. The Australian government set a goal to improve our electricity grid from 36% renewable to 82% by 2030, in line with the Paris targets. We also need to ensure our buildings will be fit for purpose in the zero carbon world. The grid interactive buildings are designed to use electricity in a smart and efficient way, shifting energy usage from times when it's both cheaper and cleaner to times when it's both cheaper and cleaner, while helping to generate clean energy and reduce costs. The paper's available on our website. I think we've actually already put a link in the chat. In its roadmap for the global energy sector, the IEA highlighted that buildings are being a crucial are crucial to the transformation of the global energy system. And they represent the largest demand-side lever available to help balance the electricity networks, support the continued growth in wind and solar, supporting the continued growth in wind and solar generation. In Australia, our buildings consume around 50% of our electricity, and around 77% of Australia's electricity system capacity at peak is used by residential and non-residential buildings. So there's a huge opportunity to shave off that peak demand, and then thus reducing the infrastructure required for Australia's electricity network. In the report, we've reported that if you can shift demand just for 3 hours a day on weekdays, so 5 days a week, you could reduce Australia's annual greenhouse gas emissions by around 0.6%, which is the equivalent of emissions of around 180,000 homes. And you could do this without decreasing energy use. So how? Glad you asked. You actually probably already know. But the market price and carbon intensity of electricity varies in proportion to the amount of renewable energy in the supply mix. When the proportion of renewable gas goes up, greenhouse gas emissions per unit of energy go down. And on the flip side, electricity generated from fossil fuel contributes more emissions. This can be seen in the chart here, which shows the carbon intensity of electricity grid in South Australia on a 5-day period in blue, overlaid with the National Greenhouse Accounts carbon intensity factor, which is in green. The emissions from 1 kilowatt hour of electricity vary from almost 0 to more than 600 grams per kilowatt hour, whereas an NGA factor takes an annual straight line approach, which glazes over the opportunities for costs and the costs of using electricity from the grid when more, and the benefits of using electricity from the grid when more renewable power is available. The report goes into this in detail, and we've got maps for the different states. So what's a grid interactive building? The components include a lot of what you guys are delivering in the audience today. So on-site energy generation and storage, lighting controls, shading, efficient windows and walls, also charging for electronic vehicles, zoning for building services, plug-in controls, and energy transformation systems. So you need some of those services that Jonathan and his team at EcoPhi are providing. And as part of this research, we hosted 3 industry workshops and found that increased sophistication is really happening in the management of buildings in the Australian market in terms of the grid. Specifically, people are working on on-site energy production and storage. They're looking at energy efficiency and demand management, as well as measurement and verification. The Grid Interactive's building paper has 4 case studies in it on cool buildings that have already made progress in this space. Do go on and download it. I'm not going to go through them now today because we're really limited in time, and mostly we want to hear from our panelists. But in summary, the GBCA is leading the sustainable transformation of the built environment. We're member-based as well, so if you want to join us, contact me. I'll link you up. Always looking for new members. The Green Star building tools require improvements in energy efficiency and carbon reduction. We're really pushing that quite heavily. And our Every Building Counts policy outlines our shared vision for policy reform, which includes reforms to encourage grid interactive buildings. Thanks for your interest in the Australian market. It's organisations that, like you, that are really driving change, and we look forward to working with you to improve our energy efficiency.
Right, thank you, Helen. So that is a great summary there. And leading into our panel as well, we'll welcome now Energate, Lunos, Proclima, and Engelmann Sensor back, and as well as Susanne. And if there are any questions, please pop them in the chat. Helen has some questions for them already, but we'll take any questions from the chat as well. Helen, I'll let you know if any come up at the end. Yeah, just to give everyone the time that they deserve, this will take us all the way to 8 when we'll finish the formal portion of the whole webinar. So thanks, Helen.
Great. Thanks very much, Tom. So welcome back to our panelists. Thank you so much for your presentations. Tom, yeah, if you can manage the chat and see if any questions for any of those 4 people come up. But in the meantime, I've got some. I'm just going to open my Word document.
Sorry, Helen, but I have to leave in 10 minutes. So
okay, so let's ask Susanne things first. Passivhaus, how can we get it here? What are the barriers?
How to remove the barriers.
Yeah, what's stopping the widespread uptake of Passivhaus in Australia the way that we've seen it take off overseas?
Well, it's a training of the professionals. So we have to offer for all the target groups training. We provide now online exams since the pandemic. So we take worldwide the same exams, and we need to bring it into the universities. I gave the example of the UK. So it's not enough to train the architects. We have to also plant now trees so they grow in the next 20 to 30 years. So bring it to the young people. You're never too young to learn about Passivhaus. And we saw some great initiatives at the conference, at the Passivhaus conference, and we need to do that more. So it's training, 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 and then also, yeah, lead by example, show the good examples and show that they work and how they are implemented in the different climate zones. So the certified buildings help.
Thanks, Suzanne.
Just for me to jump in there, sorry, Helen, it's about what Suzanne was saying, is about working together and taking leadership, looking at what needs to be done is not in isolation. We actually need to do that together, and it's great to have a forum like this. So from our end, for example, there was my commitment to Australia is that for every Passivhaus course that's actually run, we provide a scholarship. So again, has that emphasis on training the next generation that comes through. And so from our end, we really want to make sure that everyone chips in. I put in a link to Fraser's Property. They're not a small player in the market, and they actually went ahead through Kate Nason's guidance as well to actually build certified Passivhaus performance level for a volume builder. And I think what we've seen in New Zealand, the New Zealand Green Building Council and the Passivhaus Institute have worked closely together because there are some links. So if we can reduce the barriers for people, I think there was something else in the chat box for, you know, making sure that we make it as simple as easy to get better outcomes, then I think we all win.
Yeah, as James said before, sorry, Helen, that we provide from the perspective of the companies, they provide different solutions, but they should always first try to implement the high efficient solutions. And I agree, there are some situations where you then need just to ventilate one room, but we should ventilate the whole apartment, and we should guide the clients to the high efficient solutions.
Yeah, thank you. You've already answered the question about embodied carbon in the chat. I've got one more for you guys. I had one that was, well, but James, with the decentralized ventilation systems, it seems like a really great option for retrofits, almost a no-brainer. And we've got so many of those coming through as we try and tighten up our homes. But are there advantages of decentralized systems for new buildings as well?
Yeah, so there's quite a few advantages. The primary one, I suppose, for new builds is cost. So centralized systems have not just the unit itself, which is often the size of, say, a washing machine or something like that, that you have to find space for, which is, I guess, in most cases comparable between a house load of decentralized systems and a single unit centralized system. But you then have the cost of installation of ducting and the cost of the ducting itself. So with a decentralized system, the decentralized units are installed in the rooms where they're required to provide the fresh air. So there's no need for ducting, there's no need for balancing, there's no need for commissioning. The units have a bit more redundancy as well. There's not just one fan providing fresh air for the entire house. And there is, you know, fans die, they do break, bearings wear out and all of that sort of thing. If you have a lot of different smaller units working together, then you can have a bit of redundancy over the house or over the apartment or over, for example, the schoolroom, which is where if a larger fan were to break, there'd be some issues in there as well. And so those are the two primary ones, the cost and then the ease of installation. Obviously, architecturally speaking, there's ways to run ducting in places, but it is harder and more expensive. The cost of a bulkhead is quite high compared to just running a wire for a ventilation system that's already mounted in the rooms.
Yeah, great. Thank you. There's a question in the chat for me, which I'm going to answer because I'm me, even though I'm moderating. The GBCA doesn't have a green building product certification system, but we've got a responsible products framework. So there's a database of that you can upload your products into along with your environmental product declarations. We recognize loads of different environmental product declarations. So we recognize the independent third-party verifier for the products. And as a product supplier, you choose whoever you want to get your product certified with, but it's not the GBCA. And you tell the GBCA who you're certified with, and you upload your product along with that certification. And then people looking to use your product in a Green Star building will go to that responsible products framework and pull your product out of the database, and they'll be able to see what your EPD is and what values you get. You then get a score for your product from the responsible products framework, and then those scores are used in the Green Star Buildings rating tool. This is all only relevant to the Green Star Buildings rating tool. Those scores are then used to trade off different products and get more points in the responsible category. And I've just put a link to that in the chat. There's so much information on responsible products there, including a couple of free talks. But if you have any more questions about it, totally get in touch with me. I'm not the person for it, but I'm really good friends with Kat, who is, and I've done the masterclass 3 times now. Back to
Helen?
our panel. Yep, Suzanne.
I would like to add something about the ventilation topic. So we as professionals, we should be ethical people. We should take responsibility. We are the professionals of the building industry. There's trust involved, trust from the clients. So we should guide them to the solutions that actually have an impact and a long-term impact, and not say, okay, now we have installed you this type of system 5 years ago, but now look, here's the real solution. So please buy our product again and upgrade your home. No, for the last more than 20 years, we have the solutions. I know, I fully agree, there's more installation involved if you install a ventilation system that covers the whole apartment. But there's also some disadvantages of the decentralized room systems. As I said, they are a niche product for certain problems, but we have a reason why we don't certify them. We certify the other product that James showed. So we are very happy about that now. All the ventilation companies, they have solutions that are great. They are very efficient. They are silent. They have their filters, and yeah, they are real and good solutions.
Okay. We might broaden it a little bit. And Benedict, can I ask you? It's great to hear the recycling and remanufacture that's going into your buildings, and that 80% carbon reduction is really impressive, and the kind of thing that we totally reward in Green Star. But do you have an EPD for your product? Is that a common thing in the German market, and is it transferable to here?
We don't. So actually, we just started with that. So doing analysis on the carbon footprint of the product itself, we did 2 years ago for the first time, and we do that with the same agency, so notified body, regularly now. To see what is really changing also. So answering your questions in a nutshell, no, but also not a requirement so far, but we are happy to share the carbon footprint calculations of the product.
Yeah, great. Thank you. That was probably more of an interest for me. Does anyone else have any questions for the panel? Or I can ask questions all day. But you guys are the ones who we want to hear from and what you're interested in.
Helen, I can say also something to because somebody asked also if there's embodied carbon energy in our systems, so to say, documented. And I just want to add, for us, it's in each and every project very different, the geometrical sizes of what we do, so the proportion of the wood and the aluminum and the glass and so it is very specific. It's like a fingerprint. If you give me the window schedule, I can say you exactly where's the building on the world. And therefore also the related carbon content is different than there. And if there is a requirement, we are used to work with those numbers and calculate them and help people who want to work on a certified basis for those things in our windows and doors. No problem.
You're optimizing your transport and sharing the loads, like sharing shipping containers. Sounds like a really impressive way of reducing that in carbon footprint, as well as potentially meeting a couple of like-minded individuals, when saving the embodied carbon in your supply chain. And I saw a case study, well, as part of the Cambridge real estate course last year, they had a case study on a New Zealand company exporting lights, and they looked at the carbon footprint for exporting and like flat packing it around the world, which is essentially what you do, versus building manufacturing plants in the different countries, and the carbon footprint was much, much lower shipping them than setting up manufacturing bases in all the countries that they were supplying to, which is counterintuitive for people who haven't really looked into carbon footprinting in.
Yeah, and you have to also see what the products are made for. And in Germany, we have a building material class A, which means 48 or 50 years to stay in the building and to be there as long as possible. And if you see the whole time the windows and doors are made for, the initial energy of doing it is very small compared to what you lose during the lifetime, so to say, of this. And then also you have to see within the European market, and I can say that it's continental European, everywhere where we can transport with lorries from here. The market has about 500 million clients. So it's very, very big and very specific in these fields, especially if we need specific hinges or different gaskets or hardware, and we are used to work in projects in accordance to architects' demands, so we can change different setups and make these dreams happen. So this big variety is only available here in Europe, and therefore the quality needed for such a high setup, I think, is not possible to produce somewhere else at the moment. Otherwise, we would do this and go there. And therefore, shipping is, so to say, needed. But we do this also very efficient. We also, when we ship to Australia, we also change the transport route to save carbon emissions, because we don't ship through Hamburg, we ship through Koper, which saves 14 days of container transportations, and we go directly through Suez Channel as long as we are protected. That's in the situation at the moment, but therefore we already thought about the way, so we can, for example, we are also working in the New Zealand market for more than 15 years now, and in there I think this is 60 days is normal to bring the goods out there. So that's normal lead time currently.
Talking about the New Zealand market, you've obviously had quite a bit of traction there over the years. Why do you think, like, what is it about New Zealand that it's made it easier to penetrate into than Australia has been?
Well, in New Zealand, we also have different situations. We also have a consortium. It's called Ecovolution Alliance Consortium. We do this together also with partners which are here, in like it's ProClima and Lunos and Gutex, Stiepel Eltron and Energate, and we all provide system solutions. For example, for renovating houses, even that we are as individual companies present in the market and do, everybody does his own project. So we now work together as a group, and that's very nice, because then in the end, the client who wants to get a system for transforming an inefficient house in a very efficient and comfortable home, then he can get all this out of one consortium, out of one group, basically. And that's the idea behind it. And yeah, we made very nice experience with this. And it took also a long time for us to understand all what's needed with the harsh weather conditions, because I mentioned in my speech already the kilo Langley of radiations in New Zealand is much higher than in Europe. And the coastline, it's much longer than in Germany. We have only a few houses on the coast, but in New Zealand, every house is near the coast. So the corrosions are very different. So there's many different reasons and lessons we could learn in this time. Also, the packing system, how do we do this, that from unloading a container, then it has to be transported to a job site, but on the job site there is no road. And so it's very muddy out there usually when the one family houses are constructed, and then very beautiful furniture like high-end windows are placed there. But we have created boxes which are stable enough, for example, to then be also used as something else, like as transport waste. They use them not only as packaging material. So there is many aspects in all this topic, what we learned here from New Zealand, and now we are, I think, ready. And it was just the day has only 24 hours, and until now we had never had the chance to work together with somebody from Australia because we just didn't meet and start this. But now we took the chance, and we would be very happy if something comes out and people are interested in working with us.
Thanks.
I think Helen, to expand on that New Zealand situation, if anyone is interested to read more about the massive crisis here called Leaky Building Crisis, there's a really good book from Peter Dyer called Rotnomics. We distributed quite a few copies to partners in Australia over the past few years because the topic of durability becomes a major topic. So we always have this conversation around everything costs more. Well, it costs a lot when you have to bulldoze whatever you're designing and building every 10 years. And what Matthias was saying, we're normally looking for 50 to 100-year durability now. And so I think, and that's my concern for Australia, to be honest, because I've seen it all around the globe, and it also happened in Germany a few decades ago, is that we're heading for a massive crisis in terms of, I think you mentioned the mold index and other things. So we have that actually in the Australian building code now. There are liabilities attached to it, and people that don't quite understand what it actually means. And it's always the same. When people don't think about everything as a system, as Matthias was saying, it's going to fall over. And Australia is heading for a disaster.
And at some stage, the National Construction Code will be implemented for 2022 with those type of restrictions in place.
It is being implemented. It does have, in Canberra, we've actually just started here. So that's good. And we're getting a lot of questions about these new bits, particularly the DA07 and the ventilation requirements, I think I mentioned in the chat. And that's one of the, I think the things that I wanted to add as well is that the carrot is all well and good. Obviously, the target of, say, Passivhaus and saving the world and reducing energy costs and things like that is all very nice, but also there has to be a stick. And I think in New Zealand, it's colder and wetter. And the stick was that the buildings were destroying themselves over time. And here in Australia, I think the stick is that, fortunately, the building code has happened to catch up a little bit faster than I thought it would. But the stick is that buildings are going moldy and people are getting sick. And so the government has caught on and has actually changed those requirements to at least have a bit of wording around it in the building code, which allows people to point at something and say, look, this is what we should be doing. Otherwise, that stick will come for us. The rest of the world has learned the issues, learn what can happen. And so I think that's probably one of the most convincing arguments for people. And we're happy to help people make that argument to anyone who's a little bit recalcitrant in trying to say we don't need to do it. We can just open the windows. Well, not necessarily here in Australia either.
We had our annual building conference a few weeks ago, and we spoke a lot about sticks and carrots, but we also spoke about tambourines, which is having the people out there saying it works, look, we can show you it works. It's awesome. Here are some more people on Grand Designs showing you just how it works and how happy they are. So don't forget about the tambourines when you're building all your sticks and carrots, like when you're building in your sticks and carrots.
And I think what was personal experience, I was in, actually what James was talking about being in Canberra, I was in Canberra and it was a certified Passivhaus, and I used the opportunity, I had a few spare minutes on the way to the airport to go and see the homeowners, and the woman was there with her 2 kids, and I just asked her, what's the amazing thing about Passivhaus? And everyone talks about how quiet they are, how wonderful they are, how comfortable they are, how healthy they are. And then I asked her, what is your main complaint about it? She said, it's too quiet. I can't hear the birds anymore. And then she opened the door and it was so loud. It was in the afternoon. And so I recommended that she should get a microphone to put on the outside, a speaker on the inside, and then she can adjust the volume to however she wants it. But it is about controlling the environment. And that's, again, these positive stories we need to get across.
Yeah, it's weird how quiet a building can be once you've got acoustic comfort really sorted. Because we've had the same in a Green Star building, except, yeah, side note. They ended up putting a like little speaker above the toilets. So, and at Barangaroo, we've got speakers in the toilets because otherwise you'd be able to hear everything. So we've got music pumping gently, like a Japanese toilet. Any more questions while I move away from how quiet you can make your building once you've built it perfectly? We've got a few minutes left, but I might hand back to you, Thomas, to wrap up and thank everyone if we don't have any more questions from the audience, and then we can get away by 8 o'clock. Not that I have anywhere to go, obviously.
So are there any more questions from people in the audience for the panelists or for Helen? No, it doesn't look like it. Well, in that case, I'll wrap up the formal part of the evening, which has been very interesting. Lots of different presentations about different technology, lots of different expert learnings and overviews, which has been great from both Germany and Australia. I'm just going to go down the list here that I have in front of me. So Daniel's not here anymore, but thank you to him for his presentation. Suzanne's also not here anymore. Thank you to her. Jeremy, I think, is also left for the evening. Thank you to him. Helen, thank you for your contribution, and also to the companies. So Fahrenheit, Orcan Energy, EcoPhi, Energate, Lunos, Proclima, and Engelmann Sensor. But thank you very much for joining, and I hope this was useful for you and full of interesting information. So thank you very much.